Um, my name is Leif Hauge. I'm the Senior Civil Engineer for the Waukesha County Department of Parks and Land Use. I'll be serving as the moderator for today's Stormwater Workshop. This is the 25th time that my department has put it on, and the 24th time for me since I missed the first one. I'd like to thank Kelly Myers, who's facilitating this and making all the technology work, and Wisconsin Land+Water, who we partner with to put on this workshop. Some of the themes that we were going to talk about this year are using alum to enhance pollutant removal in sediment ponds. We're going to talk about cultural and historical resources, growing native plants for infiltration, shoreline phosphorus calculations, BMP recertification, stream sediment fingerprinting, the DNR's MS4 BMP menu, solar farms, municipal planning, design and implementation, water quality trading, regulatory updates, and other topics. Our schedule is to do this 2 days from roughly from 8 to 11:30 in the morning. We'll have one unscheduled mid-morning 5-minute break too, if we can work it out, but figure on something around the middle of the morning. The format's generally half-hour presentations with a 1-hour roundtable session at the end of the day today. We'll have a couple short polls about some topics that are being discussed. We will post presentations on our website. There are already about a half a dozen presentations posted. So if you search for Waukesha County Stormwater Workshop, hopefully that'll take you to the correct link on our webpage. And then those presentations would be available if you wanted to print them out and take notes on those. We offer PDH certificates. To obtain them, you need to complete the evaluation survey that will be linked in an email that's sent shortly after the workshop. And then we will email the certificates when we've received those. I'm going to give a little background on each presenter. If you have questions, please submit them on the Q&A, not the chat. The chat we just use for internal logistical discussion. So I'm going to turn off my video during the talk and then turn it back on when there's a few minutes left in the presentation as a flag that time is winding down. And for our first speaker, we have Pete Wood, who's a water resources engineer with the Wisconsin Department of Natural Resources. He's worked for the DNR since 1991, has been with the Stormwater program since 1998. Currently, Pete reviews erosion control and stormwater management plans for projects in southeast Wisconsin. Pete, it never occurred to me to ask, what did you do for the DNR between 91 and 98 if you weren't in stormwater?
I was in municipal drinking water with the unfortunately was involved in DNR drinking water program when the big Milwaukee cryptosporidium event happened, and had to get out of it shortly after that, unfortunately. But we learned a lot during that time. I do realize it was an interesting time, but decided to try something different. So
okay,
never went
well,
back
I'm
to
going to
drinking water.
turn my camera off then,
Okay,
and I'll see you in about 20 minutes.
sounds good. Okay, let's do this. All right. So yeah, thanks again for having me, Leif. We'll do our annual DNR update to start the show. When I started working on this presentation, I realized you know, did basically the same presentation last year. So and I have a lot of, unfortunately, the same information because I realized some of the things we're working on take some time. So I did manage to add some new pictures, including this wonderful DNR cartoon that I always get a kick out of. But what we're going to talk about this morning is just give you a brief update on some of the guidance documents we're working on, some of the technical standards that we're working on, and then some MS4 permit program updates, similar to last year's format. So I'll just get going through it. First, I'm going to talk about a couple guidance documents. The first one is our post-construction stormwater modeling guidance that was recently finalized. It's been in draft form for about a year, and it was available on our website in draft form, and the final form didn't change much. And this is the one that's really important for anybody submitting NOIs, doing plan designs, because this modeling guidance kind of fills the gap that are left with our administrative codes, NR 151, and our tech standards, questions that come up when DNR does plan review that aren't answered in any of those other documents. We try to stick them into this post-construction modeling guidance. So anybody who's doing NOI, especially like younger engineers just getting started, a really good reference. It's got a bunch of the criteria that you won't find in the tech standards. So the changes we made recently were fairly minor because there were some changes in WinSlam 10.5 regarding biofilter media. You've probably seen all this if you've been using 10.5. We had just added some guidance on how to manage through those changes. Um, Added some criteria. There's always some confusion about how to model street length in WinSlam again. So we added some clarifiers on how to do that. And then also, vegetated filter strips have been pretty popular these days. Modeling them in WinSlam, even though we don't have a tech standard. So this is we had to add some criteria to, kind of like narrow the world a little bit until we can get a tech standard. So there is some new criteria guidance about how to model filter strips. So that's essentially what was done with this guidance. It's available right now. If you go to our website and go under publications and guidance, you can download the current version. And this is one of my favorite. I just want to mention it's one of my favorite pictures that emphasize that stormwater ponds are also really good 100% removal at excavators. All right, so this is one that we've been working on. It seems like forever. Our MS4 swale modeling guidance is very old. It was published initially in 2010, so about 15 years old. We've been talking about for years doing some updates. Again, this is primarily for MS4s doing TMDL compliance modeling. And so what we did with this guidance is it's very similar to the existing guidance in relative to the grass swales, but through time, especially with the TMDL monitoring that's going on, people have tried to model existing infiltration basins and dry detention ponds, and questions have come up. So we added essentially separate sections in this guidance for swales, infiltration basins, and dry detention ponds. And again, this is to model for MS4 compliance existing practices. So it hopefully answers common questions, common modeling questions we get. Another change we're making in this guidance is actually increasing or actually putting some kind of criteria in for swale infiltration rate field testing. Some of you who have done this kind of work before realize it's been very popular to kind of basically better quantify the value of infiltration in existing grass swales. We did try to include some criteria about modeling existing grass swales in the infiltration of site evaluation tech standard 1002 a couple years ago. Got a lot of feedback on that, so we ended up removing the MS4 portion from that tech standard, and we're bringing it back. So we are going to have some minimum testing requirements. Right now, the proposal is a minimum of 20 tests per MS4. The better way of doing it would have been doing it like a density, like a number of tests per swale. But we know that would add up. A lot of municipalities have anywhere from 5 to 10 miles of swales. And if you did like a test per test per foot or test per mile criteria, you would end up with a lot of tests. So we're kind of establishing kind of a single value. But this guidance is going to be, it's not published right now. It's going to be going out for public comment, hopefully within the next month. And so anybody who is interested in that, we'll put it on our website for review. Gov delivery is how we also let people know things are up for review. So we'd like to hear for folks that are in this business, what they think about it. But I'm hoping I can get through with, fairly minimal comments. So that's where we're at on that one. That's coming soon. And it's going to be, it's not going to be retroactive. I want to mention that. This is going to be for folks that are doing MS4 TMDL monitoring going forward. So we wouldn't make anybody go back and reevaluate things that they've already done if their model is fine. So this would be just going forward into the future. All right, so now just to kind of review where we're at with a few tech standards we're working on. This is exactly the same slide as last year, unfortunately. We've had the dry pond tech standard under development for quite some time, but it's finally ready. This is another one that should be going out for public review within the next couple weeks. It's at the end of the process internally, at least. So keep an eye on this one. This is something that people had requested for some time, how to model dry detention ponds for getting credit, pollutant removal credit. It's not going to be, like a full replacement of wet detention ponds. Dried ponds still have the liability of possibility of resuspending pollutants, but it's going to have some criteria about how somebody could use a dry pond, let's say in a development plan, how to model it, things like that, and what kind of credit you'd get. But we do want to get some comments on it. It's the criteria is very similar to stuff we already have in that modeling guidance I mentioned, but it's actually a formal tech standard and much more detailed. The other one that's in the same boat is our sand filter tech standard. They were done at the same time, so they're both going to be put out for public comment at the same time. This is basically a sand filter is essentially a version of a biofilter, but instead of using the engineered soil mix with the sand and compost, it's straight sand. It's to deal with the liability that we've realized about the compost component actually discharging phosphorus. So this will be available as a alternative in areas where phosphorus is a concern, TMDL areas with the phosphorus limits. So this will be an alternative. It'll be the same, basically pollutant removal credit from a TSS standpoint, sand filter and biofilter, 80% filtration credit. So be ready for that one. That's coming soon. Related to that is that sand filter tech standard not only try to eliminate that liability with compost with phosphorus, is to actually have some enhanced phosphorus options. So we're going to do this in the form of a tech note. The tech standard is going to mention additives, things that could be added to the sand to actually increase phosphorus removal. We're developing a tech note to go with that to talk about some specific options. So this particular product, this zero valent iron, is an iron aggregate that has been shown in research in Minnesota to be quite valuable for enhanced phosphorus removal. This particular product out of Conley is approved for use in Wisconsin based on toxicity testing. It's being used in Calumet County on a project, so it could be used right now. In general, it's about no more than 3 to 4% of the total mix would be this iron aggregate. And this stuff comes out of Chicago. So we have based on the research done in Minnesota, a lot of hopefulness with this product working. Another one that we've been talking about is biochar, which is just wood ash processed in a certain way. Same thing added to the mix. Both of these products, the city of Milwaukee is going to be starting up a project by basically retrofitting an existing biofilter to become kind of a research facility. And we've been trying to give them some guidance on what types of engineered soil mixes should be evaluated. And right now, definitely going to have a couple different ways of introducing the iron filings. And then also recently it was discussed trying to do a filter bed that also had the biochar to actually quantify the value in Wisconsin. So that's going to be a work in progress in the city of Milwaukee. There are a couple, and then in this presentation, in this whole webinar that Waukesha County is putting out, there's going to be more discussion about the enhanced phosphorus additives. So Amy Mincer has been working on these tech standards, and these are ones that are pretty much done also, but she wanted to give a little delay so we don't have essentially 4 tech standards for public review. She's anticipating that these tech standards would be available, posted for public review in a couple months. So the first one, and I'm not going to talk in great detail about it, is based on a flow, almost like a wastewater treatment idea where it's a flow at coagulant is added, alum in most cases added to the stormwater, mixed in a certain way, and then introduced to a stormwater pond, and then the phosphorus and TSS also would be enhanced. So more treatment would occur when you add these products than would be a standard stormwater pond. So that one's coming. You'll hear more about these options again. The second one is more of a passive application. So that first one was active. This is more of a passive. This is where you would actually dose a stormwater pond, and you'll hear more about this. But and it's more of a maintenance idea, something you would do similar to like a lake treatment concept, where you're trying to use the the coagulant to kind of keep sediment from, or the phosphorus from being lost from the previously settled sediment. There's some research that shows that, obviously stormwater has phosphorus in it. The settleable part sits at the bottom of the pond, and then under certain conditions, it can be released from the pond. And that's what this coagulant dosing with a one-time event would help resolve that issue. Again, you'll hear more about these, so I'm going to keep moving along. A couple things that we're going to be working on, you'll hear about over the next couple of years. We're going to take the soil loss and sediment discharge guidance document. This is where, and I put on the screen here, the USLE spreadsheet. That's what generated that requirement. We're going to take another look at that and then actually turn it into a text standard, and maybe come up with a whole different concept. I think anybody who's been working with this tool, including within DNR, we know it's been, not maybe as smooth as we hoped. It's been used for many years. I think we're going to maybe talk about some alternatives through that process, maybe a different way of doing this. Um, and then add in some other, kind of like construction, sediment, uh, concepts, including maybe like some construction sequencing protocols, maybe some other things, kind of have this tech standard cover some larger bases. So that'll be something you'll hear about. But as you've seen with the previous tech standards, it takes some time to get through that. Another one I mentioned, I think last year, is our urban soil health team that we pulled together to look at how to improve the infiltration capacity of existing urban soils. That team, basically, we were able to generate kind of a foundation for a tech standard. So we think we're pretty far along in that, because we've done that initial work, that we could basically get moving on a tech standard and get it done fairly quickly. Uh, as far as what we're doing with that project right now, there is an active research project where we did what's called suburban subsoiling in a dead end street that was removed in the city of West Allis in cooperation with the city of West Allis and the Fund for Lake Michigan. So the suburban subsoiling was done in the fall, and this is kind of like a paired study. So half of the area where the urban subsoiling was done with the practice, and the other one was just left as a normal thing. So what's going to happen is Stu Schwartz from the University of Maryland, he's kind of the technical expert. He's going to be coming back this spring and putting in soil moisture probes and then quantifying, hopefully, the value of that practice. Based on his experience in it, I don't think there's much of a doubt that we'll see some value, but trying to quantify it, and then that improvement would be something we could develop some kind of credit system for MS4s for. So that's a work in progress. Now, finally, going to wrap up with some MS4 updates, both from a statewide perspective and from a local perspective. And I'm not going to cover everything. As you guys know, it's a big program, but just some of the points of emphasis. So I was able to get some feedback from Brooke Robinson. She's our statewide MS4 coordinator. Some of you guys remember her locally. But just we've been doing audits around the state for a certain number for the MS4s, and this is what she reported for kind of like the common issues that are coming up during MS4 audits. So I just want to let everybody know, and these are things, if you're an MS4 manager, that you can start thinking about, to be ready for a future audit when DNR comes. But one issue, and this is maybe not surprising, is MS4 construction site inspections. One of the issues that they're finding is not basically the municipality not inspecting the sites as per the permit, the frequency that's prescribed in the permit. That's been one issue. Another issue is MS4s aren't doing inspections of their own projects as we'd like to see, like let's say road projects or things like that. So that was one item. Another item is management of street sweeping and catch basin waste. And this is always an issue for any municipality, but what do you do with it? Even if you're hauling it to a landfill, ultimately, what do you do in the interim? How do you dewater? So that's been coming up, whether it's being appropriately managed, because it is, a highly contaminated, it's considered a solid waste, actually, regulated solid waste. So it has to be handled differently than, let's say, soil. Um, so, we want people to be sensitive to where they're, let's say, dewatering and how that's being handled, because it is essentially a wastewater that's coming off of that material. So anyway, that's something that's been coming up. And finally, this is one I'm going to talk in more detail about, is the old issue of long-term maintenance of privately owned BMPs. And I'm going to talk quite a bit more about that because we've been working on a project locally. For 2025, the statewide focus for audits, if you are someone who's on the list to get an audit, is going to be the post-construction stormwater management program. And that's the basically your long-term ordinance. This is, basically how you do plan review and permitting for development sites on the post-construction side, all the way to how a municipality manages those long-term maintenance agreements. So that's going to be a program focus. And then, normally what's done with audit is at least three of the major MS4 programs are included, but this will be one of them on all of the audits, and then it'll be some combination of at least two of the other programs, depending on what the particular community's issues would be possibly. So again, this is going to be a program focus. If you are someone who's on the list for an audit, they'll be talking about this program in particular. Locally, I want to talk a little bit. SamCAT is our local um, municipal stormwater permitter, and we have a large number of individual permits in this part of the state. We have about 100 total MS4s, and at least half of those are under individual permits, which is different than how um, permitting is done in other parts of the state, where many parts of the state are more general permit. But under the individual permit, SAM is able to do what an individual permit suggests, develop individual conditions. But one thing she's trying to do, and I know she's been working with many of you recently and then coming up, is to focus better permit condition language on the whole issue of BMP inspection and maintenance, especially for the private facilities. So when she's working on these new permits, definitely going to be including more different language to try to guide a better understanding of what these programs should look like within a municipality. And this is something I got from Sam also, and it makes a lot of sense when she mentioned the big picture. Like, it's really, and everyone understands this. We've been permitting, these BMPs for development projects for the last 30 years. A lot of them are in need of maintenance, and that's where the hard part is. Like, I mean, they're not going to continue to function to their best ability unless someone's inspecting and maintaining them. So that's what Sam's whole focus on the permit drafting is, to have a municipality go through and be able to describe every step that's needed to result in a BMP being maintained on private property. So one of the things, and then this, she identified these as these are the kind of concepts that she's including in the permit language, is just making sure that someone identifies who's going to be doing the inspection and maintenance of a particular private BMP, whether it's the municipality, the pond owner, the municipality, or the private owner of the BMP, or some combination of those two. That's one thing she's seeing lacking, is like a clear identification of who's responsible for what. And then actually the process of verifying, let's say a homeowners association is responsible for doing the inspection, that the municipality having a procedure to review that information, whether it's submitted from a private entity or not, and then try to figure out after that what steps need to be taken if something is found, like a pond is in need of dredging. What is the procedure within the municipality to make that happen, and compel compliance is the term that she's been using for that. So these are all things that she's trying to develop better language to address in the permit itself. Tying into this, is in the slide from last year, we had implemented over the last year a basically, we had all these tasks here are just high level thoughts of, like, how do we get to the conclusion or a better way of doing long-term maintenance, guiding it from the state level, so that we are actually having BMPs maintained. And we made some progress. We had an intern who actually, like, looked at all of the current plans that we have on record for how municipalities deal with managing long-term maintenance on private facilities. So we did look at the results, and unfortunately, we had a really hard time finding, like, really well-developed programs. That's one of the reasons why Sam's trying to clean that up. Is even though municipalities we know are doing this work, how difficult it is, of course, but DNR at least doesn't have a lot of access to a real real good, I guess we could call them like really complete plans where we fully understand how the municipality is doing it. So we're going to try to move forward on that and then try to provide some benefit. I know there's, Grace Barlow is going to talk, I think, at the end of the webinar about the MS4 BMP menu. So we're going to try to use that website to put up examples and things. So this would be part of that. We are working with some like Sweetwater, Root Pike Wind, who are also working with municipalities to try to like tackle some of these things and just kind of improve the whole program in some way, even though it's going to take many years probably. So that's where we're heading on that. Are we doing pretty good for time? Are we getting
Um,
close?
5 minutes.
Okay. All right. So yeah, I'm just going to kind of wrap up that this is like a huge topic. We've talked about it for many years. We're trying. We know it's going to take some time, but we hope we have everyone's cooperation. Another thing I just wanted to mention, we also looked at kind of the legal mechanisms. That's always been a question, especially for municipalities that are looking to claim like TMDL credit for existing BMPs that they may not have a formal maintenance agreement for. So we've also learned a few things that the long-term maintenance agreement is kind of the Cadillac, but there might be other mechanisms that a municipality has that allows them at least to have some legal authority over private BMPs, even though it might be as clean as a long-term maintenance agreement. Things like drainage easements, old like developers agreements. So I think we're going to try to compile those also. So maybe a municipality that may be struggling to figure out how to maybe gain some kind of authority over an old practice. Maybe they already have it in some other mechanism. So we're going to try to also identify those ideas and get them on the that MS4 BMP menu that's Grace going to talk about. But I think that's about it for me, Leif. Yep.
Got one audience question. Is there any
Okay.
current DNR guidance that you can point us to for implementation of following urban soil health initiative practices, i.e., decompaction of construction sites and what depth of decompaction is sufficient?
Yeah, we do. Okay, so that's where we would like to segue into the tech standard, which would answer all those questions. In the interim, I do have we did develop I guess we'll call it a summary document of the team of experts that we pulled together that has some information. We have some information also from Stu Schwartz who's done this work. So if anybody's really interested in that, they can always feel free to contact me. We haven't published anything, we haven't posted anything, but I have information. So if anybody's really interested in that, they can feel free to contact me, and I can provide the information that we accumulated through our team effort. But more to come on that, hopefully, in the form of a tech standard.
On the filter strips, kind of what were the criteria that
It's mostly just making sure, okay, because we don't have a tech standard, right? But we have allowed people to use WinSlam. It's basically kind of filling in that gap of understanding like any model, like WinSlam is a computer model, but if it isn't used correctly, it's not simulating reality, right? So some of it is just emphasizing that a filter strip has to be used in certain almost like perfect conditions, right? It has to be sheet flow conditions, flow paths need to be right, slope steepness need to be right. It needs to be because it really is an infiltration practice. You have to imagine it, and that's how the model imagines it, being able to have runoff entering the filter strip and completely flowing through that entire area of what's put in the filter strip. So a lot of it is just emphasizing that is that anybody can put anything in a model, but the filter strip is very sensitive to that. It thinks every drop of water that's entering the filter strip is evenly distributed, and if you don't have that, then the model isn't representing that correctly. Another issue is that it has some limitations, and I'm partially to blame for this. We were thinking it could be used, to model. Let's say runoff from another pervious area. So, like say a backyard draining to a filter strip, and it really can't. It's really not set up to do that. So there's some emphasis on that. It's not really meant for filter strip for pervious area. It's really meant for impervious surfaces. So that's really all it is. It's just kind of cleaning that up. Eventually, we'll have a tech standard for filter strip also that would clarify most of that. But as a stopgap, and we want people to use the filter strip function. This is what the guidance is trying to do is kind of like, limit the world a little bit.
Pete, good to see you as always.
Thanks, Leif.
Thank you very much.
Yep.
Just a reminder, if you have any audience questions, please put them in Q&A. Great. Next up, we have Richard Wiedepol, who's a retired civil engineer who spent most of his career at the DNR managing lake and non-point source programs. Since retiring, he's continued to focus on addressing lake water quality issues. Most recently, he's serving on a SOC team to help develop technical standards for enhancing phosphorus removal in stormwater ponds, specifically the 10,013, 10,014 standards that Pete was just talking about. I don't have time to read it, but Richard sent me his long resume, which is really impressive. So, he was the DNR's lake guru for years and years. So Richard is going to talk about the treating the ponds at the Alliant Energy Center that Pete showed a picture of. And I believe Kelly is going to run your PowerPoint. Is that right, Richard?
Well, Kelly, I could try the share button.
Um, Looks like she's got it up. So why don't you just go with that?
Okay.
Okay, I'm
All
going to
right.
turn off my camera, Richard. When I turn it back on, that'll be a signal that there's about three or so minutes or so to go.
All right. Thanks. I'm learning a lot about technology here, and Kelly said, "Oh, we'll do this practice in a minute or two." We went through the whole time. Anyways, here we go. So, um, we've talked about the SOC committees that we've been on, looking at phosphorus removal in stormwater ponds. And I was approached by Greg Freed, city engineer, Madison, and said, "You ought to be on the SOC committee." And I said, "Really? Why? What? They're looking at reducing phosphorus in stormwater ponds." I said, "Good. Let's I'm interested. What's in it for me?" He said, "Well, you get a free lunch." I said, "Good enough." So off we went. And I'm going to talk a little bit about the stormwater project we did, which would fall under the episodic additive dosing of stormwater facilities that is in the SOC standard that we're developing. Next. Next, Kelly. There we go. All right. The team looked at various ways to sequester phosphorus, but ended up really focusing mostly on alum, aluminum sulfate. There's other forms of aluminum products too, but it's been used forever. It's very common. You can buy it in the store, and if you want to do a little demo, and it took a little while of practice, I bought some of this alum from the store. And if you can get your pinch right, you can actually go to a lake or pond and take a little pinch, mix it into the thing, see a flock form, and clear up the water. So um, it's a very common product. Next. It's been found to be really effective at removing more things than just phosphorus. If you look at the typical dose, if you're just going to strip phosphorus out of the water column, you might use a 7.5 milligram per liter dose of as aluminum. And if you look at particulate P, you get 94%, total P 94. Very effective at removing total suspended solids, coliforms, and metals as well. So it's a very useful way of treating water. Next, here's a here's a picture of a recent project where people are applying alum, and they're also using sodium aluminate so they can do it in one time. Sodium aluminate's a buffer, it's a base, and alum is an acid. So when you're doing large projects, they'll mix these together. And this is a 13,000 acre lake. It's been done in lakes. Actually, Wisconsin did some of the first demo projects back in the early 70s, learning about using alum. Next. So, what about smaller ponds? Here's a favorite watering hole for some of us retirees in the Madison area. It's located in Verona. There's a craft brewery here. We'll meet here to have a beer, come up with some great ideas, and um, one of the ideas we came up with, well, several ideas we came up with here, came about while we were having a beer. Sometimes we actually remember some of the ideas. So next. The jar on the left shows what we took out, similar to what we took out of this pond one day while we were out there having a beverage. And my friend Dave and I were there and said, "Boy, we're not letting our dogs swim in this pond. They should be putting up signs. They should be doing something. Um, Maybe there's something we can do about this." So what we did is said, well, let's look at putting an Allen project together. Maybe we can sell that. Bottom line is we ended up working with the city of Verona, the Lake Louis Brewing people, and Dane County got a grant together and actually went and did a demo project. Next. Instead of alum on this particular project, and I'll talk more about this later, this is aluminum chlorohydrate. There's different products that you can use to apply aluminum to a pond. This particular product was one that we used because we couldn't find any local applicators to do what I'm going to show you we did later. So to get the amount of aluminum in the pond that we needed to also address the sediment phosphorus, we went with this product, which is pH neutral. There's some positives and negatives with it, but this is what we used. Next. Here's our applicator who came up from Florida. He's done more projects than virtually anyone else, many, many projects, and thought we'd bring in the expert. He brought his boat up here and applied the alum to the pond. He did it in one day using the aluminum chlorohydrate, and it's been very effective. He came back once since then to do an additional dose with the city of Verona, and been very effective. My dog loves going swimming here now. Next. All right, the project that we've been involved with that Leif asked me to talk about. Line Energy ponds are located on the Alliant Energy campus in Madison. There's basically, if you look to the left-hand side, the west side, most of the stormwater flows in from the Alliant Energy Center into that west pond, and then it goes over to the top underneath that little bridge there and into what's called the west pond or the east pond. The east pond discharges into Lake Monona. So this is a project that we ended up doing. Next. So my friend Dave Marshall and I went out and looked at it and said, "Oh, okay. I see why Kevin Connors, who is a retired land conservationist from Dane County and was an acting director, he's filling in at the Line Energy Center, said, is it maybe we could use alum on these smaller ponds and these ponds that are 5 to 6 feet deep?" And I said, "Well, maybe." He said, "Sure, it'd be nice to do something with these ponds. We've got the world's largest rock fest coming up here, and we'll get 100-some thousand people here along with a whole bunch of other things. It'd be nice to see if we can do something that improves the aesthetics as well as to capture some of the phosphorus before it goes into Monona." So we said, all right, okay, next. Of course, we went out and took our samples. Basically, it just look at the total phosphorus. They're typical of the east pond. That's the secondary pond. Total P was fairly high, 0.04. The west pond where the stormwater came in was fairly significant with phosphorus. The total area, if you look at area, we're looking at about 5.5 acres. These ponds are about 5 to 6 feet deep. And we did some fish surveys, and they had typical fish species that you'd find in stormwater ponds. Somehow they get in there. Who knows? People stock them or whatever. But we had the carp, goldfish, of course, you see, green sunfish, pumpkin seeds, and also had coontail and Eurasian milfoil in the west pond. The east pond, more secondary pond, actually had a significant amount of white water lilies. Next. So again, great ideas come when you're commiserating and having an idea. And Dave, that's my friend Dave Marshall, a retired DNR aquatic biologist, said, what about something that can be applied more easily? We can't bring up someone from Florida. We got to make this more of something that could be done more easily and much more broadly. So what could we do? Next. Said, well, I got a friend, Harry Gibbons. Harry was one of the authors of this book, Alum for Phosphorus Control in Lake and Ponds. Harry is an old friend of mine from our work in the North American Lake Management Society. He did most of the special sessions teaching people how to apply lakes with alum. And I said, well, Harry's retired. Maybe he'll help us. So we gave Harry a call. Next. Working with Harry, and here's a report that we worked together to put together. I sent Leaf a copy of this, and many of the things I will talk about can go into much more detail in this report. That basically turned out to be a cookbook for how you would go about using alum if you want to do a treatment like we did. It it's it gets into the detail on on dosing and yada yada stuff and when to do it, how long it lasts, etc. So this is something I would encourage people to take a look at if you want more information. He ended up we looked at various things. Stripping. Stripping is just applying alum and taking the phosphorus out of the water column. That's what we used to do in lakes. Typically, we'd go out and put a dose of aluminum on the water and knock the phosphorus out of the water column, so you got virtually it all intercepted. Then there's also P inactivation, and that's looking at tying up the phosphorus that's released from the sediments. Especially in older ponds, people are now finding that you get a lot of release of phosphorus from the sediments, especially in older ponds where you got anoxia and you got plant covers like I showed you in the picture where you don't get much reaeration and the bottom waters go anoxic. Next. So how much should we put in, Harry? Well, I'll tell you, given the alkalinity you had, which is fairly high in the hundreds, he said you could probably just use 7 milligrams per liter and you'd be fine. You wouldn't, if you can use aluminum sulfate as an acid, you'd be fine with that alkalinity, keeping pH above 6 or 7. But he said, maybe you want to look at applying more. So we did some bench testing. We took some water samples, worked with a local lab and set up to do some dose testing. So we took water from the ponds that we're going to treat, took them to the lab, added more precisely alum rather than a pinch to see how much we could add. Next. In this bench scale testing, you see we try different doses. You need a certain amount, 2 or 3, 4. You'll typically start getting a flock. There's certain things you need to look for. You get a flock. You need enough to get a flock. So six was you do various pH testings over time, and as you can see, we added up to 10 milligrams per liter as aluminum again, and the pH went down to 6.7. You can see the alkalinity went from about 140 to 76. So we still had a fair amount of alkalinity left. So we said, okay, we'd probably be safe adding as much as 10 milligrams per liter to these ponds. Next. So the issue here, though, was Harry suggested, he said, with ponds like this, you really want to get the sediment inactivated. How much should you put in? He said, well, you really want 40 grams per square meter of pond area. In lakes, people will look at as much as 50 to 100. They'll do sediment core testing and see how much phosphorus migrates out, how much you can apply to really lock up the phosphorus for a significant time frame in the sediments. So we said, okay, we can do 10 milligrams per liter, no problem, keep the pH up to 6. But we'll need to do it 4 times to get this initial dose in these ponds to treat the sediment. So we had to wait till the alkalinity responded. We went out and found out that the alkalinity from the sediments came back up, and we were able to retreat this pond within a week. So we spaced out 4 applications over the first season to get that dose we needed in the sediments. Next. All right, permits. I still don't know where, as Leaf might knows, when do you need a permit for stormwater ponds? I'm not sure it's still clarified exactly, but these ponds were classified by the Wisconsin DNR as lakes. They had WIBIX and said, okay, so let's get a permit. DNR has been permitting whole lake phosphorus application, whole lake alum applications for many years now, and they've come up with a process, and they authorize it under a low impact discharge permit. So it's straightforward, but it's still required a permit. So we went through the process and obtained a permit. Next. So, all right, we're ready to go. We go out there and say, oh, are we going to really spray alum onto this? All right, Harry, what's up? Can you do this? Harry says, yeah, you can treat it, but it'd be better to do something else because you have a lot of the phosphorus tied up in this. In this case, it was some filamentous algae, Cladophora, if you had taken a dissolved phosphorus sample there, you'd see it's 0. But he said it'd be good to deal with that first. Next. Back one, yeah, there we go. So when you look at phosphorus, people talk about total phosphorus, dissolved phosphorus, and when you get into it, there's about 5 or 6 or 7 different characterizations of the type of phosphorus you got. There's the loosely sorbed and the iron bound. You look at the iron bound because iron has been used to remove phosphorus, but the problem with iron is that the pH or the dissolved oxygen gets below 6. Or gets below 2, excuse me. Iron says goodbye, phosphorus. So you target the loosely sorbed and the iron bound, and then you got the degradable organic, and that's what you have with the filamentous algae. So he said, why don't you use hydrogen peroxide, treat the pond first, and then you'll have a much more effective treatment of this pond to capture the alum. Next. So use hydrogen peroxide. I said, what's that? And in Wisconsin, not many people are familiar with this, but it's hydrogen peroxide, and this product, phycomycin, is labeled in Wisconsin. You can use it. It's an oxidizer, and it'll break down the algae and release all the phosphorus. Well, why not use copper sulfate? And we called an applicator, and he said, well, I'll just use copper sulfate. I said, well, copper's not as good. It doesn't oxidize it. Copper, you got to watch out for oxygen depletions as the algae decays. He said it's a little more expensive, but it's a great thing to use. Next. So got another permit. Aquatic nuisance control permit, hired an applicator, and here he is applying the hydrogen peroxide, basically with like a lawn spreader mounted on the back of the boat, and he just drove around the pond over all of the filamentous algae and applied the hydrogen peroxide. Next. And it was interesting to watch. It did not take very long. This was just maybe a few minutes, 5-10 minutes after he applied it. And you can see how the hydrogen peroxide's breaking down this filamentous algae. Next. There's a close-up. It didn't take very long, and this settled out after a day or two. One of the other benefits of hydrogen peroxide I found out is that it actually adds a breakdown product. It's oxygen, so rather than depleting oxygen, it adds oxygen. So it's a good product to use. It the very first picture that Kate showed, we were doing another little small pond there, and in that pond we had duckweed and water meal. So I said, well, let's use hydrogen peroxide, and they found out no, it doesn't work on duckweed and water and water meal. So we ended up using a different chemical. Had to wait a little longer and cleared up the surface before we applied the alum. Next. Harry suggested using dry alum. Um, it's a simple way of keeping. It's a straightforward way for local people to apply it. Harry said he's worked with many golf course applicators and said he likes using dry alum. If you're getting into more of a routine application, liquid alum is more likely used. And in this case, we're able to say, okay, we went to Canada, Thunder Bay Chemicals, and got a bunch of dry alum to apply to the lake. Next. I'm not sure why I put this in there. I guess I have no clue as to what this means, but what it shows is that alum ages over time. Hyd- uh, hyd- the ACH that we use in Verona is further aged, so it won't last as long. But alum does age, and the other thing that maybe they point out is that when you see when you see a flock out in the lake, it settles down. You'll see it settle over the bottom. But if you look a few days later, you won't find the flock. The aluminum is more dense, and the flock readily integrates into the bottom sediments. So it's not like you put a cover over the top of the thing. You get the aluminum basically integrated in the surface sediments, and it'll continue to be effective for a significant time. Next. So there's our basic application. Use the 5 horsepower pump, a suction hose, pump the water from the pond into the container. These are just local grounds maintenance people there getting ready to apply the alum. Next. Um, One of the things we discovered is, well, you got to dissolve the dry alum. Okay, how much you put in there? Well, you need about 80 to 100 gallons of water for per bag of alum, and then you got to use a paddle and mix it. We ended up paddling with a canoe paddle for a day and had a little problem dissolving the alum, and the local guy said, here we go. So they came up with this device, poured the dry alum into the container and used this and got it dissolved. Next. So once we did that, we turned the pump around and sprayed the alum over the pond. This was a good site where you can get from shore, and you can see the flock developing there. And you try to get it as evenly distributed as you can, but experience has shown that the flock will move around, and you get fairly good coverage if you try to spread it around relatively evenly, but you don't have to be perfect doing this. Next. So what did that cost? We ended up using almost 800 pounds of aluminum. Um, the cost for this first year, and this include the treatment of the sediments, which you wouldn't do in subsequent years. You would just use a simple surface application of maybe 7, but we wanted to get more to get the sediments. So it was $5,800 for the alum, and we inactivated, given a relatively common ratio. We tied up 72 pounds of phosphorus that will no longer be available. It'll be locked up for history, and it cost us 81 pounds. So Greg, I think it was Greg, maybe it was you, Phil, that asked, well, what did it cost? I said, well, it just cost alum, cost 81 bucks for a pound of phosphorus control. And he said, well, with some of our other training issues, where you get 50 in the watershed BMPs, you're getting into something that might work. So said, oh, okay. So said, found out later that guess what? Nope. The uh, you can't get credit for the phosphorus inactivated uh, in the sediment. Maybe you can get credit for the stripping in the water column, but um, we aren't going to give you trading credits for the uh, for the phosphorus. So next. All right. So finishing up here, well, what's with this? Well, SLAM doesn't take that into account. Really? Okay. Well, maybe there's something that could be changed with that. Another thing that got me going on this was in Madison, we're looking at um, trading watershed practices to control phosphorus, and when we looked at how much credit had been given for phosphorus removed in the Mendota watershed, in 1 year, credits were given for 63,000 pounds of phosphorus controlled. Guess what? 63,000 pounds is what USGS has monitored coming into the lake. So bottom line is there's some work that needs to be done, and we got to be careful with models. Dave Schindler, one of a good guy was the first guy to show that phosphorus was a limiting nutrient, said that, and we were developing models back in the 80s on lakes. And he said, many of these attempts to describe lake processes are nothing more than a willy-nilly collection of synergistic coincidences. So, and another model one, remember, all models are wrong. Practical question is, how wrong do they have to be useful? Certainly they're useful, but sometimes people tend to look at them as gospel when you really need to keep things in perspective. Next. Long term, I kind of went over this. In a situation in the aligned energy ponds, we'll look at maybe another dose in a year. Harry says, well, pond will tell you. Okay, so it's been fairly good. We got more macrophytes in there. We don't have any algae blooms, and a dose maybe once a year is all that you'll need now. You dealt with the sediments, and it'll last for a very long time. So as I mentioned, the other thing I think longer term considerations are the issues with trading, but that's something for another day. Next. Let me finish up with carp. It's many times. Well, you got carp, and the carp are going to disrupt it, and they're going to stir up the sediments and such. The good thing about using aluminum, it's going to bind with the phosphorus, and you got carp stirring up the sediments. They'll end up they'll settle right back out again, and they may actually help some of the aluminum that still has some cycle left to be able to capture additional phosphorus. Okay, next. Kind of ran through this quickly. So got time for a question or two if anyone had any.
Yeah, Richard, we have one audience question. How long does this method last for treating the ponds? Does this treatment need to occur yearly to keep P levels down?
Yeah. When we did the Verona ponds, Harvey said that, well, we use aluminum chlorohydrate. You're probably going to be controlling the release of the sediments for 5 to 8 years. Had we been able to use aluminum sulfate, which is less aged, you're looking at controlling the release from the sediments for 10 years or maybe more. In the condition in the aligned energy ponds, we dealt with the sediments, so additional applications, obviously you got more phosphorus coming in every year from the stormwater coming in. So Harry's experience has been that probably once a year, maybe even 2 years, depending on the situation, to keep the aesthetics good and have some significant phosphorus capture.
And here's another one. Any discussion about future dredging of sediments and potential buildup of copper or alum that will trigger special low hazard contamination handling and disposal requirements.
Yeah, I know. Maybe with the copper there is, but it it's something that we'd rather use the hydrogen peroxide for. The aluminum actually, where people have captured the sludge, applied to egg fields to capture phosphorus out in egg fields. So it's actually a beneficial use.
Great. Well, we're at time. So thank you very much for taking the time to present here, and I'll look forward to seeing you again soon.
We'll see you soon, won't we?
Yeah.
All right. Thank you.
All right. Next up, we have Phil Gabler, who is a water resources engineer for the city of Madison and has focused on improving the quality of stormwater leaving the city during his time there. He has a bachelor's degree in agricultural engineering from the University of Illinois and a master's in civil engineering from UW-Madison. He has interests in green infrastructure and in creating spaces that can both treat stormwater and provide amenities to the community. And Phil is on vacation. Phil, it's 33 degrees here. Where is it? What's the temperature where you're at?
Oh, you don't want to know. It's sunny and 80 where I'm at in Sanibel, Florida, out on the balcony.
Well, I really
But
appreciate your interrupting your vacation to do this.
but not a problem.
I'm
All right.
gonna blink out here when you're getting close to time. I'll turn it back on.
All right. And I didn't carry a second monitor with me on vacation, so I'm going to try to do this on a single monitor, which I haven't done in a bit. Uh, Bear with me if this has one or two hiccups. All right. Hopefully you're seeing the presentation mode. Today I'm going to talk
Yep,
about.
yeah, we're good.
All right, great. Uh, Using alum as a coagulant for treatment of stormwater runoff in Madison. This was a project that was started in 2013, and both of the people that worked on this project have since moved on to other jobs. And so, it's always fun to go through and piece together work from someone else's presentation. So I've cobbled together four different presentations here. I also worked on this project, so I have a pretty good handle on it, but just wanted to give a little warning that some of these slides and some of the information I don't have kind of personal information or development of, but I do understand these basic concepts. So this is a pilot scale chemical treatment system on the west side of Madison. Why were we doing this? The Rock River TMDL is really driving a lot of this work. Uh, Madison's in that northwestern edge of the Rock River TMDL. We have a goal of about 100,000 or 11,000 pounds of phosphorus captured per year. And within our MS4, most of that now we're getting through adaptive management, working with Yahara winds and capturing that lower cost phosphorus out in the agricultural community. But anything that we do capture above and beyond our MS4 requirements in the city of Madison is something that we are not going to have to work with adaptive management to acquire. And then there's also Lake Wingra in Madison that does not benefit from the phosphorus and sediment capture up in the Mendota watershed. That water bypasses Lake Wingra, so there's some effort and goals to reduce the phosphorus loading into Wingra. So if we look at the Marion Dunn Pond, it's over on the west side of Madison. We have the Glenway Golf Course. If you've ever been there, some people call it Speedway Golf Course. But this area flows out into a small pond. It's a little bit undersized by today's standard, doesn't get 80% TSS reduction. Mostly medium density residential upstream. Pretty big watershed for the size of the pond, hence its low capture, but it's at 232 acres. We really, at this time, didn't have any treatment upstream in this watershed other than street sweeping And here that was monthly mechanical broom sweeping. If we look at that watershed, you can see almost all medium density residential, a little bit of commercial and a school on that far west side, and a large park in the middle. It all flows down and comes into the green area, which is Marion Dunn Pond. Zooming in on that, we have a 4.5 by 8 foot box culvert. We then have the pond, and it has two outlets, 42-inch RCPs that then flow into moderately defined channels and eventually into Lake Wingra. We look at the existing water quality in that pond, relatively high phosphorus and orthophosphorus, moderately hard at 20 milligrams per liter, neutral pH, and some alkalinity in there. We took some additional measurements, and they were in line with those historic values from 1990. We're up at 743 micrograms per liter of total phosphorus at our high count and down to about 357. This pond is also demonstrating excessive phosphorus and that there's nutrient cycling. There's a lot of algae growth in this pond. We also had some maybe less than ideal maintenance happen where we got rid of all of the kind of shrubby secondary growth volunteer trees that had grown around the berm. That's part of many ponds maintenance cycles. But when that happened, you'll see a lot of debris left around the bank, and that'll come into play later. So don't forget this picture. So we looked at doing alum treatment here. What modifications were we going to make? We ended up building a main shed, that blue rectangle here, that housed pumping pipes, the alum, and we'll go into more details on that. We had a pipe out to the pond to pull water to mix with that alum, and then it came up to the inlet where it was dropped into the pond, and we had sampling points at the inlet and both outlets. We look at a schematic of this little treatment system. We have our pumps on the left. We had alum and a buffering agent, which I have in the next slide and don't remember the name of, and then a couple small pumps to feed that into the main mixer. And then we had containment so that if one of these ruptured, we would hold all of the volume of the barrels that were on these extra storage pallets. Here's an interior photo of that circulating pump and our control center. And then the dosing pumps are these two small ones up on the wall. We had the aluminum sulfate on one pump, and then the sodium aluminate. If the pH dropped too low, we would switch over to that. Here we have the containment for both barrels of the sodium aluminate and the alum. Here's that inlet. It was that large box culvert. It had a gate on it, which we took off. That's my supervisor, Greg Fries, out there doing the dirty work. And then inside of this USGS monitoring shed, otherwise known as the mouse condo, we put in ISCO sampling equipment and did flow weighted samples of the flow coming in. And then it was the same on the outlet. The outlet here is a little tough to see, but this is a large storm sewer access structure, and we had a weighted bottle here on the upstream of a weir wall. So this weir wall had a 6-inch orifice in it, and then it had this permanent pool on the upstream side, a weighted bottle with a chain on it, and then that would do the level recording with data loggers, and then there was sampling equipment. You can see the hoses on the back to capture water as it went out of the system, and an area velocity meter downstream in the pipe. So here we are. You can see that gate's gone from where Greg was standing before, replaced it with some PVC pipe. And during rain events, this only was active while flow was coming in and the pond was at an elevated state. We would dose with the alum. It would mix in the pipe and then be discharged into the incoming water. And you can see that it would start to form some flock and some foam pretty quickly and then move out into the pond. So if we look at kind of one of our better monitored and sampled storms, here we have the August 28th and 2015 event. This storm came in 3 peaks, and we were able to, take 7 samples on that first wave, 6 on the next, and then 4 more. And then we were a little selective due to budget on our outlet samples. We didn't run all of those, but we did run, we got representative outflow samples. This was one of our better monitored storms. There was a lot of issues we had to work with on this, but this one is kind of what we were hoping for. So this is a really, really overly numeric table here. I think for me, the take-home message is we had a variety of inflows coming into this storm or into this pond. We had storms that ranged from, very, very high frequency recurrence intervals, let's call it a 2-month storm, all the way up to ones over a 10-year. We measured the in and the out, and we calculated a total phosphorus reduction. And we weren't quite sure how to then compare that to anything, so we decided we would compare it to Windslam. If we compare those total phosphorus reductions to Windslam, if the number is red over here, that means that we, even with the alum, we under captured phosphorus. Here, pretty significant deviations on the front end, but this was year 1. We were still working through a fair amount of bugs. We go back to year 2, and lots and lots of samples, okay phosphorus reductions. Some of them were quite high. And then if we look at that August 28th, 2015 event, right, that was about a 2-inch rainstorm, put it kind of right at the 1-year recurrence interval. And the alum dosing was sized to be able to fully treat a 1-year event. As you look at this event, you can see that we had that 72% TSS reduction and then a 51% phosphorus reduction. We compare that to what we had in Windslam, is kind of spot on. But that was with the alum dosing. Moving on to 2016. By 2016, we had figured out a couple of our issues. We knew we were getting some backwater effects in the pond. We had a lot of issues with clogging at the outlet structure. We put some Band-Aids on our system to try to make it work better. And we were getting, for some of the storms, we actually were able to get it to work the whole storm, and maybe nature cooperated a little bit during those events. And we had, when we compared to Windslam, better average increases over the Windslam predicted values. So how does that make sense? I mean, if you look at that August 28th storm, when we go back, we think we ran out of alum at one point in time during the event. So we only dosed the front end of the storm. But we didn't have a float inside of the alum tank. And so the pump was telling us it was pumping. Everything we were looking at with our telemetry said, hey, this is working fine. And then we got the results back, thought it was odd. And also when we went out there, we noticed that the alum tank was empty. So we definitely had some startup pilot issues, but by year 3, I think we had worked through these. And this table right here, that we were able to go from a predicted 43 to a 56. We're getting about a 10% increase in our total phosphorus capture. Oh, that is total phosphorus, not TSS. I'm sorry, I miscircled the column, or mislabeled that column, or switched those. Sorry. If we look at this now, comparison over time, right? All those numeric charts we saw in a graphic form, you can see that in 2024, the blue line is our phosphorus reduction. The green box is our predicted phosphorus reduction. We were pretty below predictions in year 2014. 2015, we were a little closer and had some up and down. And then by 2016, we were above our predicted values. I think this is just showing that we finally got our system dialed in and made the changes we needed to make sure we dosed the whole storm. So kind of the summary from this is that although this is really variable and pretty messy data, uh, this was compelling enough that we were going to explore a much larger and full-size chemical treatment for stormwater treatment of the Yahara watershed. This was the Starkweather Creek coagulant study, which is available, and there's presentations out in the world that you could look on that study. Essentially, we're taking a quarry pond and converting it into a treatment pond that would take storm flow out of Starkweather Creek, dose it with aluminum coagulant, designed it as an upflow filter, and then capture that sediment. Due to, there's lots of things of putting the treatment pond in a urban environment, and this project ended up getting put on the Horizon list and is now, say, 99.9% sure that it's not going to be constructed. But at the end of the day, it was modeled to capture a lot of phosphorus and sediment that would otherwise go straight into Lake Minota. So we learned a lot in this project. One is that having this complex triggering mechanism, right? We had to have flow in, we had to have the pond level at the right level. It then would adjust the dosing of the alum. These things are complex, and when you add complexity, you add opportunities for failure. This is one form of failure. The pump stayed on and continued to dose the pond with alum after the storm inflows had stopped. And so we had to run out and turn off the pump and try to figure out what was going on. So telemetry is a must. If we didn't have this set up so that my phone was giving me an alert, it would have been a problem. We could have put all the alum in the whole tank out. Another one, this watershed had a lot of coarse debris. That picture we had before where we were showing all that debris along the shoreline, that debris did not decompose in the pond over the 3 years we did the study, but it did get stuck on our outlet. And that happened again and again. It clogged both that 6-inch orifice and the gate on the outlet pipe. We ended up putting this debris guard around the edge to try to hold it and let it fall into the pond. If you got a storm that went over that debris guard, it did nothing. And this is not a good pond to monitor when you have an outlet structure that looks like this. So maybe picking a pond with less vegetation and not doing the vegetation maintenance right before we did the study would have been a good idea. But on the flip side, ponds with high organic loads are potentially worse phosphorus providers. The alum supply and winter storage. This is something that's pretty critical if you were going to go out down this adventure. One, alum freezes at a warmer temperature than water, so you shorten your alum dosing window unless you have a heated shelter, and you don't want your barrels to freeze and freeze in your pump. So we ended up having to winterize this every year. If you could have heated it, it could have stayed, and you would just have to blow out the lines. If you're going to remove the alum, it's really important to have easy access for a forklift and trucks. That's something this site also did not have, so it was really a pain to get things in and out. Again, it was a pilot study, so all of these things were not vetted and thought through that much. We're like, well, we can endure this for a little bit. And then the biggest one, if you're doing as you start, is just make sure you have enough alum. It's really frustrating to have everything work right and then run out of alum mid-storm because you didn't connect two barrels together. So that's what this is. This is a picture where we just fixed our hosing and pulled from 2 tanks of alum, so we doubled our supply for a long duration storm. Last, consider your outlet structure design. This pond had 2 6-inch orifices through a large weir wall. I know we have many private practices that go down to a 2 or a 3-inch orifice. If this study taught me anything, it's that a 6 and or an 8-inch orifice is very, very easy to clog. And we likely have a lot of ponds out in the world that are not functioning how they're designed because those orifices are partially or totally blocked. This pond would stay at the top of the weir wall for days before enough could flow through the clogged outlet structure. And here's kind of my conclusions and takeaway. The aluminum-based coagulants dosed during rain events can increase your TP and your TSS capture, right? There's potential benefit out there, but nothing's free. The added complexity makes these systems more prone to failure than passive ponds. And with the guidance for aluminum, you have the potential to now go past your kind of permit requirements by overdosing your ponds with aluminum. You want to make sure that the additional maintenance effort, right? Checking all those pumps, the sensors, the increased notification of clogging that might have been missed, all those are rolled into your cost benefit analysis before you put forth money to implement one of these systems. It's these all the complexity, I think, also pushes you towards wanting to focus this on a pond that treats a larger watershed. And in a lot of ways, my take is that until you start to get either reduced credits for a standard wet pond, because they're showing that they may leak out more phosphorus than we thought, until we get to that point where we have reduced credits until you are dosing with an aluminum-based coagulant or some other dissolved phase phosphorus binding material, I think this is a pretty low return on investment. And with that, I'll take some questions. I'm going to turn off my screen share so I can see people.
So I take it the city didn't consider continuing to operate this system for the long term. It was just a pilot and got the information that was needed, and then it was dismantled at that point.
Correct. There, this was a short-term project from the beginning, and some of the maybe shortcomings of the design is that we just said this is a 3-year project. It was on Arboretum land. They didn't want that main shed and all the piping on their pond forever as well. So that was known from the beginning.
Well, I don't have any audience questions, so if you send me the contact information for the place where you're staying, I'll pay for some Mai Tais.
Well, thanks, Leaf. And I hope people learn something from this. I will say it was the amount of debris that came through that pond was shocking to me. I mean, it's a mature watershed, a lot of tree canopy, and the Glenwoods Children Park, which had some erosion issues of its own, that all ended up in this pond. And so that pond got pretty beat up over the 3 years that we were out there. I was just amazed at how many sticks and leaves and then gravel we pulled out of that pond.
I saw the sort of chain link fence type thing that you put upstream of the outlet. You must have kicked around some other ideas on kind of more clog resistant screens, or did you come to any conclusions about that?
That was our third iteration, the one I showed. We had some that were below water, and we were just trying to, catch some of that stuff on as it rose up and then not impede flow, and those did nothing. Having the screen as high as we did seemed to be the best option, other than essentially dredging the coarse material out of the pond. I think that might have been the better course, all said and done.
I think I saw that the outlets were like 42-inch pipes or something like that. Was the clogging issue mostly because you had the monitoring equipment and you had to protect that? And if you weren't monitoring, then a larger orifice that was less susceptible to clogging would have made that issue go away?
Well, No, so this pond was designed with those 6-inch orifices to
Oh,
have the
okay.
water quality benefit. And so it's that bounce between, for your 1 year event, that bounce window of about 1.5 feet.
Mhm.
I think this pond had been underperforming for years because the orifice was fully clogged. And then you just had a 5-foot weir wall as your water quality control
Got it.
structure.
Okay.
And the vegetation around the edge didn't really enjoy being submerged by 1.5 feet of water.
Yeah. Well, I can't tell you how much I appreciate your taking the time to do this and hope that you have a wonderful rest of your vacation.
Thanks. Have a good day,
Okay.
everyone.
Thank you. Well, we're 5 minutes ahead of schedule, so why don't we take a 5 minute break here, and then at 9:30 we'll reconvene, and our next presenter, Bill Alms, will be up. So see you in 5 minutes. Yeah. Yeah, thanks for testing that. I All right. I hope that everybody is fully refreshed. And so our next presenter is Bill Alms. And Bill is a senior project manager and principal at WSB's Water Resources Group with over 16 years of experience serving clients with their water resources engineering needs. Bill's experience includes planning, design, and construction management for a wide range of water resource projects, including water quality treatment, BMPs, and erosion stabilization. He has experience with shared green and low impact developments, utilizing standard and alternative storm management systems, above and below ground infiltration, filtration, and detention systems, and rainwater harvesting and reuse. Bill is currently leading a pond maintenance research project with the University of Minnesota and the local Road Research Board. He has a MBA from the University of Minnesota's Carlson School of Management, and also an MS in Environmental Engineering from the University of Nebraska. Bill, I appreciate your taking the time to join us. I'm going to turn off my mic and my video, and when I pop back up.
All right, thank you. Hopefully audio and video are coming through.
Yep, both are good.
All right, great. All right, I am going to give a little presentation, kind of move a little west from the previous projects into Minnesota area. Project I'm going to present on has a lot of similarities to the previous two projects, and a few kind of unique pieces that we cover as well. Let's see if all right. Going through an overview. So the project location that I'm presenting on is in a first ring suburb just north of Minneapolis, St. Paul, downtown area in the community of St. Anthony Village. This alum treatment project, pond project, was constructed to meet a TMDL for Silver Lake, which is in Rice Creek watershed. If I can get my anyways, stuck to my annotate bar here. Okay. Okay, so the Silver Lake is shown, like I said, was just north of Minneapolis, in the city of St. Anthony Village. Also has some tributary area from the city of Columbia Heights, which is just to the west of St. Anthony. Surface area for this lake is about 70 acres, with a 10x subwatershed, just under 700 total acres. This lake receives some upstream drainage from Heart Lake, and then has an outlet which discharges through a couple county ditches through Rice Creek, and then ultimately to the Mississippi River. Silver Lake was put on an impaired list in 2002, and a TMDL was created for Silver Lake in 2010 for excess nutrients. And for the city of St. Anthony, which covers about 50% of the subwatershed, the roughly a 40-pound reduction, 31.5 pounds was assigned to the city of St. Anthony. So the map on the right kind of depicts in red areas that really didn't have any existing BMPs or treatment opportunities. The areas that were in gray had some treatment, either stormwater ponds or other devices. But so this entire subwatershed was reviewed, looked for opportunities on what could be done to try to get this 31 pounds of TP removed annually. Both internal and external loads there was, but the 31 pounds is really focused on a watershed based loading. So through urban retrofit redevelopment opportunities, rain gardens, improve adjacent parks to the north of the lake, treatment structures, really looking for a lot of different opportunities. They scoured kind of the watershed looking for these. The tough part is that this fully developed watershed, very little opportunity to construct additional ponds or filters or other conventional treatment systems because of either depth of storm sewer. The whole subwatershed are tight D clay soils. So volume reduction opportunities are very limited. And so overall, trying to target or find locations to get to this 31 pounds proved to be very challenging. There's other opportunities through management, education, and regulatory controls, but again, with a fully developed watershed, mostly single-family residential. There's some in this Apache area, which I'll talk about in a second, some limited redevelopment opportunity, but the vast majority wasn't going to see any full or large-scale redevelopment where regulatory controls could be put in place to try to capture some of that load reduction. I don't know why my slide advance is moving so slow. But anyways, so Salo ponds are two traditional NERP stormwater ponds that were constructed with the Apache subwatershed redevelopment. There was a Walmart in the southwest corner, Cub Foods grocery store, and other kind of just downtown redevelopment. So over the past 10 years, well, 20 years now, they're seeing quite a bit of redevelopment in this watershed turning over, but the stormwater ponds that were already in place really kind of continue to serve and meet the regulatory treatment obligations. These two ponds are shown here at 60% and 48% removal from the phosphorus that routes through them. The pond sequencing goes south pond, is slightly elevated, flows north into the north pond, and then ultimately that north pond moves up through Silver Lane up into Silver Lake. So there's about 80 pounds of phosphorus that was coming off of the two subwatersheds to these Salo ponds. And then ultimately there's about 30 pounds of phosphorus that was leaving them, which was what we identified through all of the various options and alternatives as the most attainable phosphorus to target with the treatment project. And so similar to some of the other kind of more temporary projects that were previously presented on, WSB has created a portable flocculation treatment system. It's basically a roll-off dumpster that we fabricated some interior components to pump water from the water body, inject with alum, settle, and then pump back into the pond, and then whatever flocculant or phosphorus that was removed as part of that process was connected to sanitary and discharge. So this operates very similar to a water treatment plant type system from alum, as opposed to, I think, a lot of alum when we think in stormwater ponds, direct injection in the pond and then either settling out in the pond itself or inactivating sediments in the bottom of the pond. This process is grabbing that phosphorus and removing it from the system entirely. So we looked at our feasibility study looked at a number of locations on these ponds on where system could be constructed. Of that, 29, 30 pounds that was leaving, our goal looked at trying to find opportunities where we could remove up to 26, 27 pounds was kind of the overall project target. This project was also favored or desired because of really getting after the dissolved phosphorus as direct source into Silver Lake. Removal of that dissolved phosphorus was, identified to have the greatest impact on improving the water quality in Silver Lake. So as a result, we applied for several grant funding. In Minnesota, there's a grant source called PSIG, which is Point Source Implementation Grant Funding, which is targeted specifically towards projects to achieve TMDL compliance. So this project, and then the local watershed district also contributed some money through their cost share grant program. So overall, the construction cost was bid at about $430,000 on this project back in 2015. All said and done, the construction cost of the project ended up being at $450,000. So we were able to get 45% of grant fund, or of the project, funded through grant dollars. The other aspect is, again, I kind of mentioned there's a lot of urban redevelopment kind of setting the downtown core for the city of St. Anthony. Both of these ponds, you can kind of see in the southern pond, there's a amphitheater and an adjacent, kind of on both sides of that pond, and walking paths that go around both of these. So really kind of solidified a piece of that urban core. And so another benefit for elevating the treatment and the water quality in these ponds, serving that downtown space. We did, similar to some of the previous presenters, jar testing. We looked at straight alum, and then we looked at an alternative that included a coagulant or a polymer to aid in coagulation, which local Hawkins, who's a chemical manufacturer in the Twin Cities here. They do a lot of in treatment plants. But AquaHawk was the product that we ended up selecting. The initial recommendation was the third jar test at 125 parts per million to get the concentration elevated down to a 0.03 milligrams per liter TP. What I'll talk about in the results, we actually found that we are able, with this polymer, are able to use a significantly lower dose, which is advantageous. Alum costs money, especially when it has a coagulant in it. And so the more that we can expand lower the dosing and get the same treatment results, the less O&M costs we got to provide, and then the longer between refills in our alum tanks. So overall goal is to get the biggest bang for the buck without overdosing and wasting chemical. So moving into final design, we talked about the feasibility. We've identified this. Again, in that urban central park within the city, there was not a desire to have any above ground features, sheds, buildings, temporary tanks. City really wanted this to be out of sight, out of mind, not as sort of more of a passive part of how these ponds function. And so what we ended up constructing was an underground vault through using two 10-foot diameter manholes to act as clarifiers. And we built a underground box vault that would pump water from the lower north pond, inject alum into that stream, run it through the pump, and then there are two three-way valves that controlled when they're in one position, they route water into each of the clarifiers. When they turn and go into the other orientation, a effluent pump turns into more of a suction pump, is attached to a floating strainer and pulls water out and sends it to the south pond. The south pond, if you recall, was elevated above the north. So then we create a loop in sort of a batch treatment capacity. After time, as the flock settles out in the bottoms of these clarifiers, another three-way valve that can drain these tanks independently is connected to sanitary right in the adjacent street. and so that bottom section of sludge and aluminum bound phosphate can be discharged to the sanitary sewer system. This is just kind of a plan view of that same schematic where the intake pipe coming from the northeast from the north pond goes into the vault, goes into the two holding tanks, and then it's pumped down to the south, and then there's the sanitary connection line running into the street shown. This is some of the design drawings. On the left is that clarifier, that 120-inch diameter, 10-foot diameter manhole clarifier with the floating strainer on it, and the sanitary connection at the bottom of the tank. And then the cross section on the right of the screen is our two holding tanks, the sanitary valve in the bottom of the vault, and then the pumps that pump in and out in kind of on the left there. We had originally set this system up to have both alum and caustic soda. We didn't know at the time how much pH would be an issue or how much buffering would be required to make the system work. The nice part about the alum with a polymer is that it can be, again, used at a very low dosage, so it doesn't significantly change the pH of the water. And by using lower dosages, we actually never filled the caustic soda because of the corrosivity and the nature of that. We kind of left it in reserve, and so far we've been operating for 10 years and have not needed to utilize that. And so the benefit then that we've ended up with is we actually now have two 500-gallon containment vessels that could be doubled up or to use for more alum if needed for expanded treatment. So moving into construction on the system, we've got up in the top left corner, this is the fused HDPE intakes that were dropped into the bottom of the ponds. We put these in to try to elevate above the bottom, not to suck a bunch of pond sediment in with our intakes constantly running. The water basically pulls up just a couple feet off of the bottom of the pond, and then the discharge into the north pond is very similar to that. We did end up having the city had just recently constructed that 39th Street where the sanitary sewer was going in, and as a result did not want to open cut or tear into that sanitary manhole to connect. So they pushed to directional drill that's sanitary outlet line into the street. And then in the bottom left, you can kind of see those two are clarifiers, and then the treatment vault box, which is set on top of a 48-inch manhole where our sanitary valve is located. This is up in the top left corner is the blue pump with the motor. That's the intake pump. Goes up, and then you'll see the first three-way valve on the left. In the bottom left corner, there's two three-way valves that go out to the clarifiers. And then on the right side, this is the effluent pump, so that you can kind of see that the water moves almost horizontally through this vault until it hits the pump and then goes out to the north pond. Top left corner here is kind of a picture of what it looks like. Obviously, we were in the middle of startup testing here, so it's a little bit messier than what we usually would see out here. You just see a couple series of manhole lids and aluminum hatches, and the control panel is all that was really visible in most conditions. We did construct these clarifiers. We have these large diameter, 36-inch diameter lids, which are nice if we need to get down in, do maintenance in the vault. However, they are pretty big bear to remove and open. And so we added little 12-inch inspection ports to be able to drop sludge judges in to check on how flocks were forming in the bottoms of these vaults. And then the bottom pictures here shows our chemical treatment skids. Again, they're set up to have both caustic and alum, but they also can be combined and both pump and kick out alum into the treatment system. And then the three-way sanitary valve is in the bottom right corner. So startup testing on this system, these images kind of in the bottom left corner to the left, not quite as crazy green and full of the vegetation is actually pretty good in these ponds, but you can see the just overall clarity and dirt and other sediments that are in that pond or in that intake water. And then jar on the right is what the water looks like going out. Wouldn't say it's drinking water, but it certainly looks that clarity from what's being returned back to the pond. And then in the right is a sludge judge. So what this does is it's similar to a drinking water or wastewater treatment system. This is dropped into the clarifier all the way to the bottom, and then there's a little stopper valve at the bottom, and then you can lift this out and you can see the formation of the flock. And so what's nice, or a good visual in this image, is that this was after the tank was or the influent water was dosed with alum, tank was filled and raised or filled up to the top, and then after 10 minutes of settling, you can see almost all of that flock and sediments and other alum and phosphorus that was bound to the alum settled to the bottom within, really consolidated nicely with the addition of that polymer. So some of the results here on the treatment system, the TMDL concentration assumed for these ponds modeled and was just below 0.19 milligrams per liter. We had some pre-sample. We weren't quite that high with some of our pre-project sampling. We were probably within the 0.12 to 0.18, but the TMDL was all built around that 0.19, so that was kind of what we used as our benchmark. And then the green line here represented that objective of removing that full 27 pounds or 90% of the dissolved fraction. While we didn't get that good of performance, we certainly still showed a significant reduction in the phosphorus concentrations in these ponds. And we ultimately, as we kind of looked about this and thought about it and studied and the performance, we found that when you look at the ponds as a whole, you've got two sedimentation basins, and then you've got this alum treatment system as a sort of a secondary filter or an addition to it, is really the best way to look at it, because we get a rainfall event that flows into these two ponds. We view it that clean water, or that very high quality water that exists within those ponds, is what first gets pushed out downstream into Silver Lake. And then after the rainfall event, we can pull that sediment, or I'm sorry, we can keep treating that water. So you can see the average concentrations here down in the 0.44 average after 10 years of operations, and a 92% treatment efficiency of these ponds on the subwatershed is very, very positive. I'm almost wrapped up here, but I'll just add a little bit of clarity on what's going on with Silver Lake. A lot of projects in the watershed, some internal, some external. But one of the nice or big key stories that we're seeing in Silver Lake is the clarity that's coming. We're seeing over 20 feet of clarity Secchi readings that kind of shortly after this project probably contributed to it, but are definitely seeing an upward trend in clarity in the lake, which has been very positive. And the lake is currently being evaluated for whether to be delisted as no longer impaired. So very, very positive results from that standpoint as well. with that, I think that pretty much wraps up the summary of this more kind of permanent alum treatment system on a pond.
Bill, one audience question is, why did you decide to send the phosphorus back to the sanitary system? I guess as opposed to basically putting it back in the pond, but inactivating it in the sediment.
Yeah, that was definitely a component of evaluating, like, do we just use the ponds as the reactor to hold the sediment? The one of the things comes into permitting in Minnesota. Alum treatment systems in ponds are a specific regulated activity on as part of the city's MS4 permit. And there are, the amount of aluminum and other constituents are controlled in terms of how the annual dosing that or the concentrations that can be recorded there. So one of the ideas was just trying to capture and remove both sediments and other particulates and send them to the sanitary to reduce that buildup in the pond. There's still some that goes in there, but yeah.
You mentioned, I think, $450,000. Was that for the infrastructure construction? Did not cover O&M?
Correct. Yeah, that was the construction of all pumps, vaults, and work that was done to put this system into place. O&M on the system does vary. We have found over the last few years, we've kind of changed some of our practices and limited our operation windows to just when we're kind of going into more of a monitor the concentration in these ponds. And then once it gets above a certain level, then we'll kick the system on. But the last 2023, the alum does cost on the order of about $8 a gallon. And they probably put in about 1,000 gallons of alum over the course of the season, plus other costs. So I definitely would say that the investment is in the 10 to 15,000 a year annual operating when it is running. But 2024 was positive, where we actually didn't even need to put the system online because concentration stayed so low.
Do the vaults, since they're in the ground, do they stay warm enough that freeze up isn't a problem, or did you have to provide for heat during the winter?
There is like a small milk crate heater that the city puts in there, just kind of temp control on it. But it definitely, the geothermal aspect of it helps with that. The city does winterize the system. There's some blowouts that they just kind of shut the intake and outlet valves and then blow the water into the vaults, just kind of clean things up and keep the maintenance on it tight. But yeah.
Have you ever come up with a dollars per pound of phosphorus number?
Yeah, I wondered if that question was going to come up. We are currently in conjunction with the watershed district doing some additional study and O&M costs. I don't have all of the annual costs from the city pulled together yet, but it's definitely a high. It's not going to compete with like your stormwater ponds. It's definitely one of the higher end costs. And I would say that this watershed, I think there was another comment from a previous presenter that talked about scale or size of watershed. I would say that this, 80-acre watershed is definitely on the smaller side for what I would consider this type of a system. This size, I think, could definitely probably treat at least twice the size watershed that it is and still operate. So yeah, we're looking into that right now and trying to summarize all those costs.
What made you decide to go in the kind of continuous treatment direction where you're taking water out, treating it, and returning clean water versus treating, runoff as it flows into the pond?
Well, in this watershed, there were very few opportunities to treat that water that goes into the pond. Again, a fully developed area, the opportunities to actually capture and remove this scale of 25 plus pounds of phosphorus a year in one location that's relatively accessible. There wasn't a lot of alternative options that we were able to identify that could meet that scale. And so the two existing ponds that flowed from one to the other really provided a nice base to build off of with this augmentation system.
Well, Bill, thank you very much for taking part of your day to present here. It was really interesting.
Yep, thank you.
Okay. All right. Kelly, do we have Zach Stencil online?
Yep, looks like Zach has joined.
Okay. All right. Zach Stencil is the DNR's Departmental Historic Preservation Officer and Archaeologist. Zach's a professional archaeologist and the DNR's Historic Preservation Officer. He works in the GEF2 building in Madison. Zach served with the DNR for 2 years and as a CRM archaeologist for over 15 years. His background research includes Great Lakes archaeology, human and animal skeletal analysis, underwater archaeology, and GIS. He received his BA in anthropology and classical humanities from UW-Madison and his MS in archaeology and GIS from UW-Milwaukee. Zach also serves as the vice chair of the Wisconsin Burial Sites Preservation Board. And Zach's going to be talking about the historical review process and how that works. So, Zach, welcome.
Thanks, Leaf. Can you hear me?
Yes, we can. I'm going to
Okay.
turn my screen off, and when I pop back on, it'll be a sign that time's running down.
All right, fair enough. Let me share my screen. There, is that coming in,
Yep.
Leif? Okay. All right. So as Leif said, I'm the DNR archaeologist, or rather one of two archaeologists. My counterpart, Ricky Kubicek, reports to the Milwaukee office. So there's two of us for the whole state, and both of us are considered the department's historic preservation officers. So as the DNR HPOs, we act as the liaison between the department and the Wisconsin Historical Society, as well as the State Historic Preservation Office, or SHPO. So a little background on kind of what we do on the day-to-day. So my job as at DNR HP is to make sure that, first of all, our department internal actions comply with both state and federal historic preservation laws. So you can see here a whole list of the different tasks that we do. The most common thing we do are the compliance reviews. These are our desktop reviews using GIS and the Wisconsin Historic Preservation Database. Next on the list, my favorite thing to do, archaeological surveys. So actually getting out into the field, boots on the ground and shovels in the dirt, looking at existing cultural resources and sort of navigating our internal DNR projects around sensitive cultural sites. So here you can see some candid shots of myself at the top here doing some shovel testing along the Military Ridge State Trail, and then my counterpart, Mr. Kubicek, doing a surface survey of a sand blowout here at up at Newport State Park within an existing Native American village site. Other things we do, burial site monitoring is another field component to the job. going out and being on site during project activities within human burial sites. We also do interpretation, so going out to the properties and giving tours and talks. We do trainings, such as today, and then also planning and advising for DNR projects. Data requests for GIS data to our property managers, and then we get involved with the master planning, stakeholder coordination, and at the end of the day, if there's any time left, maybe we get to do a little research, but I haven't seen a lot of that lately in my 2 years at DNR. All right, so again, our most frequent task at DNR are what's called cultural resource reviews, or CR reviews for short. So these are the desktop checks to make sure projects are in compliance with the state and federal historic preservation laws. So not only do we do the reviews for the DNR projects, so this sort of internal review process that we have, but we also do reviews for projects that are submitted to us from outside applicants. So this could be folks requesting permitting. We're doing grant program participations. We also do a lot of real estate exchange projects where a cultural resource review is required. So you can see here is a whole list of our DNR sections that do their own review and then kick us the ones that need the extra cultural resource reviews. So stormwater at the top, of course, because today's Stormwater Day. Forestry is probably our most common reviews, just because DNR kind of holds a lot of forestry land in trust. But we also see projects from water quality, waterways. You can see the list here. We definitely have our brains wrapped around a whole different groupings of different types of projects that require these cultural resource reviews and the compliance with that. So here's some other pictures here. I got a lot of pictures of just DNR properties that have cultural resources on them that we've had projects working on in the past. So feel free to ask any questions, or if you're interested in some of the parks and what's there as far as archaeology goes, feel free to ask me that at the end of this. All right, so what do I mean by cultural resource preservation compliance? So why do we do what we do? Well, first of all, because it's the law. So I'm gonna talk a little bit about our state historic preservation laws. DNR HP operates primarily under Wisconsin Statute Chapter 44. So the first subchapter in this one deals with the historical society itself, sort of the creation and responsibilities of it. And then the next subchapter 2 really outlines this historic preservation program that we operate under. So I have a couple statutes called out here that are important to kind of consider. 4430 here states that the historic, architectural, archaeological, and cultural heritage of the state is among the most important assets of the state. So basically it's written into law here that historic preservation serves the best interests of Wisconsin state citizens, sort of as a sort of backbone of why we're doing what we're doing. Next important statute that I want to call out is 4434. This says that the State Historical Society shall create, update, and maintain the Wisconsin Inventory of Historic Places. So this inventory is very important to 4440 state regs, and we use it in our day-to-day reviews for cultural resources. So at a basic level, what are historic places? So aside from having to be at least 50 years or older to be considered historic, an historic place can be many different things. This can include both areas of land where there's subdeposits of archaeological resources, but it can also include physical buildings and structures, which a lot of people don't think about. So as far as archaeological sites go, examples of that include pre-contact villages. We have rock art sites, fur trade era sites, even effigy mounds and historic logging camps are considered historic places. And then again, it can be these buildings or structures. So A sunken vessel, Lake Michigan and Lake Superior are full of shipwrecks. Those are historic places. Structurally, a cabin or a lighthouse, or even a bridge can be considered a historic place. And last on the list here, you can see that even, yes, an outhouse can be considered an historic place and listed on the state inventory. So to give you a sense of some of the numbers in Wisconsin for cultural resources, within the state, there's approximately 25,000 archaeological sites that we know about, 9,000 burial sites, including both active and ancient. They're both considered the same under state law. And then about 157,000 different historic buildings and structures, monuments, shipwrecks, all the things that would fall under that category. DNR, as one of the largest state landholders, also has a big chunk of these numbers. So on DNR state lands alone, we have roughly 2,500 archaeological sites, over 600 human burial sites that we manage, again, active and ancient, and then hundreds and hundreds of historic buildings and structures. So here's just a couple pictures of some examples. Lizard Mound State Park up at the top. We had a hazard tree removal project there this winter that they had to be careful around the effigy mounds. And then some restoration work up at Rock Island at the boathouse there. So a real wide variety of resources that you may or may not consider to be historic. So I mentioned the inventory of historic places that WHS is responsible for both creating and maintaining under 4440. So the Wisconsin inventory is maintained by WHS, and they call it the Wisconsin Historic Preservation Database, or WHPD WIPT. So this database is constantly being updated with new sites, new data, new pictures, new maps. Archaeological site boundaries are constantly changing based on survey work. So fines versus no fines can expand or truncate an archaeological site boundary. And this data is organized by resource type. So you see here, I have it called out as ASI, represents archaeological sites. The AHIs are architectural history, so those structures and buildings. And then the ARI is the archaeological reports inventory, which basically just references previous archaeological survey work and gives it a sort of a spatial element as well. So just for example, I have the Wild Rose Fish Hatchery, which is up in Waukesha County. This is one of their entries from the database. So this would be considered an AHI, an architecture and history inventory piece. Here you see the Wild Rose Fish Hatchery called out. And then here's an image of it, these concrete raceways were used to house and raise fish. And then this rather busy map here in the lower right is the topo map that is within the database that shows the GIS polygon data. So we have orange polygons for the ARC sites. You have these blue dots everywhere, which are different historic buildings and structures. And then you have these yellow polygons, which represent that previous archaeological survey work. So a lot happening at Wild Rose. Jumping back to historic preservation law, 4439 is where my job as a historic preservation officer is written into law. So 4439 states that each agency appoints one of its employees to serve as the historic preservation officer. So DNR, DOT, PSC, they all have their own HPOs, which act as that in that liaison position with the state historic office. And then 4440, this is kind of the actual teeth of the law for historic preservation. And that reads that each agency considers a proposed action of the agency, how it will affect their historic properties, and then it directs the agency to cooperate with WHS in efforts to identify and protect the state's cultural resources. So from 4440, that's where my job as HPO is to prevent adverse effects to Wisconsin's historic places, which are those resources that are called out in that inventory. So if it's not in the inventory, then it doesn't comply as far as state preservation law is concerned. And then the other state law that we operate under is our Human Burial Sites Protection Law. So this law is housed under Chapter 157, and this chapter deals more broadly with human remains in general. So you see I have the first couple subchapters called out there that they deal with things that morticians and funerary homes have to deal with, but not anything I deal with. And then subchapter 3 is where this burial sites preservation law kind of comes into play. 15770 deals with the identification and the protection of human burial sites. And you can see here I have it called out where site disturbance is prohibited, and then any uncatalogued burial sites will require permission to disturb from WHS. And then catalog burial sites may require additional permissions from State Burial Board. So really the key takeaway from 15770 is that if you ever have a project that's within a burial site or directly next to a burial site, it's sort of out of my hands as a DNR HPO as far as permissions and next steps. Those are things that are in the control of the Wisconsin Historical Society, and those permissions need to be requested from them directly. So there's a specific procedure for that, and I will touch on that a little bit later to help you. All right, and then lastly, I'm just going to briefly touch on Section 106 because it doesn't come up too often with stormwater permitting, but it does occasionally come up. So Section 106 of the National Historic Preservation Act, this requires federal agencies to consider their effects of the project to historic properties, both listed on our inventory and not listed. So this is potentially a big difference. If there are already identified resources in the area, it's kind of the same as 4440, but if there's nothing there, then additional investigations may be warranted. Projects that require Section 106 compliance include any projects that are on a federal land parcel or on a parcel that was purchased with federal grant money. Projects that utilize federal grant money is a big one, and there's a whole bunch of different agencies with all their different grants that will make your head spin. And then projects with direct federal oversight as well. So those are the main ones that trigger the federal historic preservation law, Section 106. In our case here, for example, a lot of, I know waterways permitting projects, this comes up a lot, sometimes stormwater, but when you get the Army Corps of Engineers involved, that's a case where at DNR HP, we sort of request that federal compliance review from Army Corps, and then we will defer to their clearance if they already completed a Section 106 review. All right, so the culture resource review process, as far as a stormwater permit is concerned here, again, by state law, it has to comply with 4440 and 15770. If it's being submitted to DNR for permitting, that kind of then falls under the umbrella of these state historic preservation laws. So I'm going to walk through a couple of examples of projects that have come across my desk in the past couple months, and kind of show you how we handled each one. So I have an example of what we call a false alarm, no culture resources coincident, an example of an archaeological site, and then also an example of a historic property, and then lastly an example of a archaeological burial site. All right, so for this first project example, the false alarm example, so this was a project submitted to our stormwater team for review. Basically, the project is to redevelop a parcel and turn it into a car wash place called the Foam Farm, which of course I had to read a couple times before I figured out what it was actually doing. So for the initial screening, applicants sent in the project to Stormwater at DNR for permitting. Our section reviews projects and looks at what we call the quarter maps for cultural hits. So instead of actually streaming the whipped database data for specific polygons, we have an agreement with our reviewers to send us anything that's within a quarter section of a project, just so that we can catch projects that may be either mismapped or that are adjacent to an archaeological or cultural resource site that would need some further attention. So that was sent to us. We did our CR review, and it turned out that the project was not coincident with any historic places. And the project did not have a federal connection to it, so no federal nexus. So you can see here, this is the project area on the map with the Historical Society's database streaming to it. It's right next to one of these yellow polygons. This is actually what I told you about as a ARI, a previous archaeological survey. So for my part of the review, I go into the database and I request that survey report. I review that in regards to the project area and make sure that there was no recommendations for further investigations or anything like that. Once I can affirm that there was no further need for investigations, I send out sort of this boilerplate all clear email back to my reviewer at Stormwater, who then forwards that on to the applicant. So in this case, the project was cleared. No cultural resources are present within or adjacent to the project area. And then I always add this disclaimer at the bottom: if the project changes in the future and maybe federal funding is added to it, then it's up to the applicant to resubmit that back to us so we can do the Section 106 compliance review. Okay, next example here, we have archaeological sites, and in this case, multiple. This was for a project to do some dredging of Browns Lake. So you can see the project area is to dredge all this extra sediment out of the lake. And then their project plans were to create a pipeline and to dump it at several dewatering locations. So the whole project area of effect was reviewed, and we found these coincident archaeological sites, multiple sites that hadn't had a full investigation of before. And so we instruct the applicant to contract with a cultural resource management firm to complete an archaeological investigation of the overlapping site areas. So they don't have to do an investigation of the entire project area, just where the archaeological sites are. Once that survey work and the reporting is completed, then those things are submitted back to us for additional review. We look at the report, we look at the findings. If the project is not going to have an adverse effect, in this case, these archaeological sites were only the reportings of a few artifacts discovered, so nothing really significant that would require further investigations, and therefore we were able to clear the project per our 4440 regulations and then release the hold. All right, another example. This one involved historic buildings. So another 4440 compliance project. This one involved the construction of Kalahari Lake Delton tree houses. So another bit of Kalahari action up in the Dells. After our review, we determined that the project was going to demolish several buildings in the project footprint. So you can see the map here at the bottom has a lot of these AHI point data. So they're illustrating historic buildings. And so we were able to say, yes, we have coincident AHIs. Yes, there's cultural resources in the project area. And what are the project plans to affect those? Well, in this case, the plans were to demolish the buildings to make way for this new resort area. And you can't get any more adverse than demolishing buildings. So in this case, 4440 became involved. When dealing with historic buildings, sometimes it can be a little bit confusing, and I'm not an architectural historian. So if I can't determine if a project, if a resource per se is going to be demoed, if that resource is historically significant or not, I can defer to SHPO for their review of the project. So in this case, I sent the project to SHPO for additional review to determine if the buildings were, in fact, historically significant, or we call it NRHP eligible. So that just means, is it eligible for listing on the National Register of Historic Places? This is just a sort of a criteria standard for determining if a building needs to be protected or not. So SHPO reviews the project, they sent it back to us, and they determined that indeed no eligible properties would be affected, meaning that these buildings are not historically significant, and they weren't going to require any sort of mitigation work before the buildings could be demoed. And then, of course, we take that approval from SHPO, we forward it to the applicant and give them the all clear on their project. All right, and then my last example here, an archaeological burial site. This one is for a road reconditioning project in Sauk County. The project was going to increase the size of the roadway, both in width and depth, so there was going to be an effect of ground disturbance. Our review found that, yes, there was an archaeological burial site. You can see the polygon down here, the roadway goes right through it, and they were going to be doing some digging outside of the existing asphalt. So again, per 15770, the permission to disturb a human burial site is required. And in this case, the applicant took it upon themselves to complete that request, following the steps that I'll share with you in a minute here. And then once they received that permission from WHS, they forward it to us for project clearance. All right, so I'm gonna get through this pretty quickly here. So basically, what can you do to make this process smoother? So what can you do to get ahead of the game, let's say? So the first things you can do, you can pre-screen your projects. I'm sure many of you might have access to the WIPT database. If not, you can purchase a user agreement on an annual fee, I think, and then you have access to the database to look at historic resources. If you're interested in that, you can contact this email address. You can also click on this link down here that'll take you to their website. And I've made this PDF of this presentation available with active hyperlinks, so Leif can share that with folks if they're interested, or you can pop it in the chat, Leif, and everyone can grab it at their whim. So next thing you can do, if there's a cultural hit, it's helpful to identify the resource. So again, if you're using the database to do your reviews preemptively, what helps me to review your project is if you've already called out the resource. What kind of resource is it? Arc site, historic site, burial site. Is the resource previously disturbed? Can you prove it based on pictures or aerial imagery? If it's a historic building and it's showing up as a blue dot in the database, but the building's already been demoed, again, proof of that, pictures, overview maps. WHS doesn't remove those blue dots from the AHI. Once a building is demoed, they just make note of it. And a lot of times that's not updated. You know, I do a lot of the updating for them with that. So basically address the resource, write a little narrative that, hey, we know there's an arc site here. Here's a map, and then next steps to follow. So that would save you some time. Another huge time saver is if you have a coincident burial site, go ahead and request the permission from WHS preemptively. WHS has 30 days to review a project before they need to respond. So that would save you a whole month's worth of time to already have that request to disturb the burial site in and then back again from WHS so that you can add that to your application packet when you're requesting your permitting. Easy steps to follow at this link here. So get the PDF and click on the link. And then what you would do is fill out a form, attach all your project info, and you'd send it into this email address. And then lastly, if you really want to get a jump on things, I can't recommend this enough. Just go ahead and hire a CRM company to handle historic preservation regulations. And I'm speaking to this from experience. I've worked in CRM for many years with many different companies in Wisconsin, and being that sort of liaison between historic preservation law and requirements definitely saves a company time and headache. I've been the point of contact for We Energies, MG&E, WPS, Alliant, Enbridge, all of them saving hours and time of headache going back and forth trying to navigate compliance issues here. So when in doubt, and if your project's large enough, hire a consultant, a professional in the field. And this link here is a list to all the consultants that are approved by the Historical Society to work in Wisconsin, both for archaeology and architectural history. All right, and lastly, additional resources. So a bunch of links at the top. If you're interested in historic preservation law and want to dive deeper into that. I also have a link here to our Office of the State Archaeologist, who does projects across the state and sort of weighs in on these compliance issues. The SHPO review process, if you're curious or want to take a stab at it yourself, that's the information you need. And also the submit a request to disturb information and where to download the form that I mentioned. Aerial imagery, if you're interested and curious, you can look at images from the 1930s. So zoom in on your grandparents' dairy farm or something and check it out. That's a fun site to visit. And then these last three deal with, as I mentioned really briefly, the NRHP criteria and eligibility, how we make our judgment calls as far as whether additional investigations are required or if they are not required. So this is where you can find that criteria when dealing with historic resources. All right. I think I threw enough at you. Leif?
Oh, that was super clear, Zach. That was really good.
Thank you.
Well, there is one question. Is there a way to access WHPD without purchasing an online subscription so that project planners can more easily design to protect historic sites? I'm guessing the answer is no.
Well, up until relatively recently, you could actually make an appointment and go in, and they would let you access the database. If you follow the link to where I said to purchase the license agreement, follow that link and it'll give you more information on how to access that database, including ways without having to buy the whole data agreement or a subscription to it.
We've already posted a PDF version of your presentation,
Okay.
which has all the lists and stuff that you provided there, but none of the links will be live. I'm wondering if you could send me a copy of the PowerPoint, the PPP file.
Okay.
That
Are you sure
we
the links
perhaps
don't
find a
work?
way to post that, and then we'd have live links.
Are you sure they don't work? I was able to open the PDF in Acrobat, and you could click on them.
Oh, then in that case, never mind. We'll post that and hopefully.
Yeah, give it a try, Leif, and if it doesn't work, then of course I can definitely send the.
I just assumed that in the PDF they would just be frozen, basically. Well, Zach, that was really great. Thank you very much.
You bet. Thank you.
Kelly, this would probably be a good time to run that poll from Reluca Allen about native landscapes. Could we do that? All right, so audience, please take a crack at this poll. We'll give it a couple minutes here. While that's running, I'll introduce our next speakers. Reluka Allen is a senior project manager with Good Oak Ecological Services based in Madison. They work exclusively with native plants and local ecosystems, offering comprehensive design, build, and installation services ranging from urban and pollinator gardens, rain gardens, erosion control basins to ecosystem restoration, prescribed burning, and erosion control plannings. Danielle Bell has a passion for the outdoors, starting as a small child, exploring the natural world with her parents. After receiving her BS in Conservation and Environmental Sciences and a BS in Architectural Design, she's worked in the green industry for over 10 years to manage properties composed of a variety of native habitats. Watching the delicate and unique interactions between native flora and fauna strengthened her passion for the natural world and led her to start her ecological restoration company, Native Roots, with the focus of reintroducing native plants and controlling invasive species in the landscape. Neil DeBall began his involvement with Prairie Nursery in 1982, producing native plants and seeds and designing native landscapes. In addition to popularizing the use of native plants long before they were cool, Neil developed the first scientific methodology for designing prairie seed mixes in 1985. He also designed and installed the first rain garden in 1986 in Sheboygan Falls, Wisconsin, and the first native seed mixes for detention basins in Sun Prairie, Wisconsin, and bioswale in Fitchburg in 1989. And then Julia Robson is an ecologist at the county's Retzer Nature Center. And Julia, I didn't get a bio for you, so maybe you could just briefly introduce yourself.
Sure. I apologize for that. I was in Mexico getting married, but I have no excuse because Danielle was at my wedding. So thank you. I've been a conservation biologist with Waukesha County Parks for going on 8 years now, but I've been working in the natural resources management field for about 16 years, predominantly in wildlife habitat management, but pretty extensive background with getting native plantings installed and doing maintenance, particularly as it comes to prescribed burning and invasive species control.
Great, thank you. Reluka, this is your poll, so can you see it? You're muted.
Hi, everyone. Yes, I can see it.
So what do you make of the results?
Well, it was a trick question, and the answer is actually all of them. So I just kind of wanted to give an example of how many ecological functions native landscaping provides.
Right, okay. All right, so this is intended to be a roundtable discussion. Neil drafted up a short PowerPoint that has a handful of, like, about 8 talking points. Neil, how about, why don't you bring that up and share your screen, and perhaps you could lead the group through the discussion. Would that be okay?
That sounds great. I see my video is disabled by the host according to this, or at least it did say that. So, oh, okay, start my video. Okay. There we go. There we go. Excellent. Okay, beautiful. So we'll bring this up here. And here we go. So we have these 7 points, and we kind of passed this around till we reached agreement on what the most important items are. These are not necessarily listed in the order of group importance, but rather in the basically the process that is typically utilized in designing, installing, and managing stormwater basins, etc. So first of all, you want to decide, are you going to use seeds or are you going to use transplants? And there are pros and cons for both. And of course, site preparation is really important. With more and more regulations, we're seeing the use of engineered soils, so site preparation becomes less important because we're putting in a potentially almost sterile soil. So that's a great advantage over using native soil. And then, of course, the soil conditions, like we talked about, is going to be an engineered soil, local substrate. What do we have to do? Do we have to somehow adjust a local substrate if we're not using an engineered soil? And then the plant selection and seed mix selection to match to the site conditions. And again, these can vary depending upon hydrology, soil conditions, etc. And of course, erosion control, very important. We can use EMATs, we can use nurse and cover crops, we can use mulch, and then post-planting management basically are, because these are grassland ecosystems, wetland, grassland sedge ecosystems, they can be managed either with mowing or burning. You may want to do some spot herbiciding if necessary. And then finally, first year watering. This is kind of an ancillary issue, but it's really, really important to make sure that you get good establishment, especially when you're using plants. And there's a very significant investment in the cost of those plants and the labor to install them. So you want to make sure that they have the absolute best chance of survival. So if we put plants in the spring, we're going to want to have a watering system available all summer, just in case there's a drought. And normally, if we install plants in the fall, it's usually not a big problem unless we have a dry spring. So those are the 7 major topics that we selected. So do you want to just go down item by item, Leif, or what's the best way to handle this?
Well, why don't you go to your next slide?
Okay.
And if you could just recap what's there, and then we could give each of the panelists a chance to weigh in.
That sounds great. So a lot of people, in fact, I just got off the phone with someone in Illinois who's designing a project for Crystal Lake, Illinois, and he's got a lot of pressure on him to use plants because they will provide much quicker results as far as blooming, flowering plants, and of course they will provide quicker establishment. Usually, in many cases, a lot of the species will bloom in the first growing season. Seeds generally require 3 to 5 years to become completely established, but plants, it's all that time versus money. Plants cost on average 10 times more than seeds per square foot, and the labor costs to install plants are tremendously higher than putting down seeds. And the other issue here, and this is the deep, dirty secret of transplants, you spend all this money, and transplants have spaces between them where weeds can become established. And so, are you really getting a better result? Typically, we get better results with seeds because we have better coverage. We don't skimp on the seed. We're putting down 60 to 100 seeds per square foot, maybe more. And if we get a 2 to 3% result in that, we're going to have at least two plants per square foot, maybe more. And most projects do not allow you to use plants any closer than 1 foot per 1 plant per square foot, and some are less than that, leading to all sorts of weed problems. So seeds are my preference if I want a cost-effective methodology that will fill in completely in 3 years. But if you're under pressure to get quicker results, you have to use plants. And then you have the issue of combining plants and seeds together, which have completely different management protocols. If you put down plants with seeds, you can't use any pre-emergence to prevent weeds because that will stop your prairie seeds from germinating. And because in the first year of a native seeding, you typically kept weeds mowed at 6 inches, you're whacking back the plants that you spent all that money and labor to put into 6 inches. So you're not getting the advantage of all those plants. So there's become some very problematic issues there. You can raise your mowing or weed whacking. You're not going to take a mower in there. You can raise it to 12 inches, which will preserve many of the plants that you installed while providing halfway decent weed suppression for the seeded areas.
Well, why don't we open the floor? How about I'll just say, open it up, and whoever would like to comment should just go ahead.
Yeah, I agree with Neil, like that, doing seeds is more economical and you do get a better coverage for competition against weed seeds germinating because you have more native seeds and a better coverage of them across the whole space. And some of those, if you have a good seed mix with a high diversity and you have those early germinating quick species, like sometimes we've seen really good success with cardinal flower, Rudbeckias, monkey flower, even like some of those, they can really germinate and flower in that first year. So if you have a good mix of not just when the plants are going to bloom in terms of diversity, but also in terms of habit versus, those early germinating quick annual species and some longer lived perennials like, compass plant and things like that. If you have that good diversity mix, you're going to see results pretty good with doing just a seed versus having to do the plugs as well.
I agree also. Sometimes we also do get pressure to use live plants instead of seed, and they work excellent at a small scale, but it gets very expensive very quickly.
I'll just echo that as well. Most of our projects are fairly large in scale, and seed is the most economical decision to use. And as Danielle mentioned and Neil alluded to, just the design of the seed mix, which we'll get to, can lend well to meeting those other objectives that we're kind of touching on right now. But on smaller scales, obviously transplanting with plugs and even we've used native vegetative matting before in certain situations, again, smaller scale, because that's even pricier than the plugs can be. But it just depends, I think, too, just on the scale. Scale is a big factor here too.
In the context of infiltration basins, sometimes they can be kept offline where for a period of time you don't have runoff passing through them and the seeds, the plants can do their thing. Sometimes you can't. And my question would be, in a case where that basin is going to be getting runoff right away, does that make a difference in the seeds versus plants decision? Do plants do sometimes better when they're suddenly getting inundated occasionally?
I think that depends upon the erosion control methodologies that you utilize. And even in fairly high velocity, high volume situations, we've been successful with seeds as long as we protect it properly with EMAT. And the issue here is that you want a heavier EMAT for higher velocities, higher volumes, but you don't want so heavy a mat that it impedes the emergence of the dicotyledonous species that can't push up like a grass or a sedge. So there's kind of a trade-off there. But even we find that Excelsior mats have worked very well for us because they seem to have a little more integrity than straw mats. Now, people may have different experiences on that. They both do work. But for some reason, that wood, I think maybe it has just more stability. The little wood shavings in the Excelsior mats seem to hold up a little bit better in my experience. I like to echo what Danielle said, is that about the faster growing species, a lot like the biennials and some of the short-lived plants like cardinal flower. Elymus canadensis and Elymus virginicus, man, those are the workhorses to get things going right away. I always, I put oats in there. We'll talk about that too. I put oats in there because that's like, boom, that's your first line of defense. And then comes the Elymus. And by the end of the first growing season, you got a solid cover with Elymus virginicus and canadensis. So you get past that first year, you should be in pretty good shape.
Anybody else?
I'll just reiterate too what Neil said with the plants per square foot, doing at least 100 seeds per square foot. If not, I mean, it's so much more cheap to increase that seed mix quantity instead of having to come back later and overseed because something didn't take in one area. If you just, up it by 1.5 of the recommendations or any of the specs that are listed, that little bit extra, the couple thousand there versus having an infestation of invasive plants come in, it's well worth the effort and the cost up front.
I can double my seed rate or get 2 more flats of plants. I'll take the seed.
Definitely. On the live plant side, we have had great success planting in double net coconut ematting, planting the live plugs in there with minimal weed problems. Otherwise, for seeding, as long as the emat is installed properly, the seed holds. I probably would not use mulch for live plants, as that's what just flows away immediately and smothers the plants when you have a considerable rain event.
All
Can we
right.
move on? Ready?
Yeah, next slide, please.
All right, you got it. So site preparation, obviously we want to be as completely free of perennial weeds, grasses, woody material, anything roots, depends on the situation, but usually we don't see that when we're dealing with engineered soils. But when you get into local substrates, that can be problematic because you have no idea what's in there, and oftentimes the contractor may not have prepared it properly, and there's rhizomes of quackgrass or brome grass or Canada thistle. My God, who knows what's in there if they don't follow it properly. And then if you have compacted layers, especially with heavy clay soils, that's got to be broken up or there'll be no infiltration. And of course, fertilization is rarely an issue, except for deficiencies of certain macronutrients like phosphorus and potassium, or what I call the mesonutrients, calcium and magnesium. So is that slide cut off? Can you all see that okay?
Yeah, I think if you hit the slideshow button down at the bottom right,
Yeah,
it should go
maybe
full screen then.
that's in the bottom right.
Bottom right of your screen.
Okay, where is that?
It's the little thing with the kind of upside down T on the bottom.
I am not seeing that, Leif. Let me see here. Why am I not seeing this? This is odd. So slideshow. Oh, here we go. Let's try this. I think, yeah, I didn't get it in the right.
There you go.
How's that? There we go.
Yep.
Okay. I didn't set it up right. Thank you very much. Okay. So, what do y'all think? Everybody's in perfect agreement. Did I miss anything here? I know we've all seen this because we shared this first, so it was pretty much a group effort here.
Yeah, I'll just add to this. One thing that we keep in mind when we're looking at doing restorations or just reconstructions is not even, what's adjacent to the project area. It doesn't hurt to kind of assess that as well, because that's likely going to be, a seed bank or a seed source that you may be fighting against with establishment and maintenance. So if there's things like teasel or canary grass in the vicinity of a project site, just things you may want to be aware of when you're working to get something established, because those will likely be species that may show up in the early stages of your eyes peeled for what's beyond the scope of the immediate project footprint can be beneficial.
That is so true, isn't it? And when I work with clients, I recommend if they have problems like Canada goldenrod, teasel, Canada thistle, especially airborne seeds, to mow those down right after they bloom before they make mature seed that can blow into their project. That's really super good point.
I would add with the engineered soil, it's great and sterile, but sometimes when we're required to use compost in the engineered soil, we do see a lot of annual and biennial weeds right away. Probably airborne, immediately got into the retention basin, and I feel like the compost is just making them explode.
Yeah, this is a really interesting question. What percentage of the projects that you all work on are you using engineered soils, and what percentage are you using native soils where they maybe have to be modified?
We work a lot in Dane County, and a lot of the requirements do ask for compost in the engineered soil. Sometimes sometimes we get a little bit of a leeway there and not use the compost, but I would say about 50-50 engineered soil and just local substrate.
What do you do when you have a problem local substrate, Reluca?
We invest a lot in stewardship and weed management post-planting. Yeah, when we have the opportunity to introduce prescribed fire to within year 3 or 4, I feel like the composition of our planting changes for the better quite quickly. Otherwise, a lot of mowing and some herbicide application.
As long as we're on weeds, one of the biggest problems, of course, is reinvasion or invasion by reed canary grass. Have you all had problems with that, and what have been your strategies to control it?
Yeah, lots of problems with that. So just thinking one of our project sites at Fox River Park, our best success has been with getting in there with early fire just to get the thatch, obviously remove the thatch off of the planting area so that we have better accessibility with the chemical control options, but it's usually multiple applications throughout the growing season. But I've seen the best results when we're able to get in there after a spring burn in particular, or if we had a dormant season burn prior as well. But that's usually the option for us is broadcast applications after fire, because in most of our sites the scale is just too large for doing things like cut and bundle or anything like that. But it's been constant. We've been able to keep it at a lower density, but we're within the Fox River floodplain at this project site that I'm working at, so it's going to be a long-term continual maintenance issue.
So are you using grass selective herbicides like cefoxidum and clethodim?
Yeah, when in the portions of the planting zones where it's obviously not wet, we've been using clethodim and had good success with that, particularly when it's been applied on overcast days. We've definitely noticed that it's reduced activity when it's been applied on sunny conditions, which is it's known with clethodim. So we've had success with that. Other than that, we're using rodeo or aquatic approved glyphosate.
So general spectrum, it kills everything.
Well, in the zones that it's been thick, yeah, but we work to try to use the grass specific where we have a bit more intermixed with some of the natives that have established well.
And you're using a crop oil educant with the clethodim?
Yes.
Have an audience question here. How do we fight against non-native plants if we're not using engineered soils? I guess referring to reusing soils that maybe are, topsoil was stripped, it was temporarily stockpiled, and then it's been reapplied to the bottom of the basin with any seeds that were in it.
Well, when I work on a project, I say, kill the weeds on that stockpile. Don't let them get established. And if they're okay with using glyphosate, spray it every 2 months, because 2 months is usually the time required for some annuals to make seed. So if they apply it every 2 months, then you can stop annuals from seeding and perennials from becoming established. So that's the strategy. And also before excavation, if you have enough control in a design build situation, you specify that the weeds must be controlled prior to excavation, so you don't have perennials that are moved off, put in a pile, and then moved back on, just completely defeating the purpose of it. So that's how we handle it. I'm sure other people have different methods too.
In our experience, we see a lot of kind of subpar site prep before seeding, and that just kind of turns into a constant stewardship battle. Yeah, herbicide, mowing, and fire on repeat.
I'm a firm believer in prevention. Ounce of prevention is worth a pound of cure. But most people don't, they're so busy to get their projects done, they don't want to take that into consideration. And that can sabotage the whole project.
I think
There's
again,
another question. I'm sorry, go ahead.
again, like using the cover crop grasses, if you're on a time crunch to get things done, if you just throw a bunch of the Elmis plants, the Canada rye, Virginia rye, at least you have a good cover crop of grasses. And if you have broadleaf weeds coming in like the goldenrod or Canada thistle, you can at least use a broadleaf specific herbicide on those and keep your cover crop of those early germinating grasses, and at least you have cover and you're not getting any new seed coming in and getting established after you're taking out, if you have like a big carpet of teasel, you kill that with an herbicide and then quickly get some of those early germinating plant seeds down. And then at least you got something fighting against any new seed germinating or any new plants resprouting. So using that cover crop as much as you can. It's inexpensive and it's sometimes, cheaper than obviously having crews go out every couple weeks mowing.
And you were recommending the Elemis grasses for cover crop?
Yep. The Canada rye, Virginia rye, riverbank rye, bottle brush grass, even if it's a little bit of a shadier site, even if it's sunny, those ones all germinate fairly quickly. And there's even some sedges too. Brown fox sedge germinates fairly quickly, we've seen in our experience. So sedges can get a little bit more expensive. So depending on, how bad and how big the area is. But just getting something good on there on that space.
And that
And
element, I'm sorry.
another audience question, if you spray topsoil stockpile for weeds, can prescribed erosion control stabilization seeding survive? I think often in erosion control plans, we require that something like annual rye be placed on a topsoil stockpile that's going to be there for an extended period of time.
You can just add annual rye or oats, and when you spray it, you just reseed it. That's not ideal, but you're not disturbing it, so all of the dead material is there to hold, the dead roots are there to hold it in place, and you just go and broadcast seed. I like to use oats because annual rye, if it's allowed to go to seed, can infest that soil and can be a real problem if there's too much seed. When you go to seed it, especially in the fall, it'll come up in September and it'll be thick the next spring, which will help suppress weeds, but it can also suppress your native species. So I prefer oats because there's no danger to your planting because the seeds just don't survive.
Yeah.
I was
Well,
going to also say what
well, I
back
was
to what
going to say,
Danielle.
just to keep things moving, I think maybe we should move on to the next slide.
Yeah.
Got about a half hour left.
Okay. So we kind of talked about soils. I don't know if we need to really spend much time on this, but one thing that can be an issue is you have local sandy soils. They're already providing excellent infiltration, but they will not support wetland plants during summer dry periods. So you have to adjust your mix to a broadly adapted generalist species, like your big grasses, like big blue stem. If height is not an issue, switchgrass, big blue stem, which have these extensive root systems that really stabilize and encourage infiltration, and they'll grow in dry sand to almost a wetland. And then of course your broad spectrum like bergamot and yellow coneflower, a wide variety of stiff goldenrod. A lot of these plants that have really broad amplitudes that can tolerate flooding for 5, 6, 7 days, but also can tolerate drought for a month. Did anybody have any comments on soils?
When you say clay-based soils, you're talking like 30-40% clay.
Yeah, like silty clay loams, even silt loams. That they don't have that great an infiltration capacity, and so it defeats the whole purpose. So then you say, okay, what do I do? Assuming they're not compacted, where you don't have to go in there and dynamite them out. But you can always add organic matter. But the issue is you can only add soil amendments so deep into the soil, so the deeper soil profile, still will be limited in its infiltration capacity just because of the tightness of those clay and silt particles. So then you have issues of water retention and what's the actual period of time of inundation. So your inundation times will be significantly higher in a clay-based soil compared to a engineered soil or a sandy loamy sand soil. So now you have to change this, not change, you have to select the plants that will tolerate flooding for 3, 4, 5, 6, 7 days. So it really does make a big difference as far as your seed mix or your plant selection when you have these native soils that are just slow infiltrators. Next one.
Sure.
So this kind of follows up on that. Select your plants to match soil texture, drainage rates. And again, that expected maximum water depth and inundation time. Super important. That's the first question I ask is what is the design inundation time and depth? Because that's your limiting factor. That's going to determine how much moisture those plants are going to be able to be exposed to. So that's the number one question is what's the maximum water depth and inundation time? That's the deal breaker. That's the limiting factor. So, and then generalist plants, fox grasses and sedges for soil stabilization. I agree with Danielle. Brown fox sedge, Carex vulpinoida. That is the workhorse of our rain gardens, retention basins, because that sucker will grow in the sun. It'll grow in the shade. It'll grow and it'll take. We grow it in sand. I'm like, what's it doing in shade? It'll tolerate growing in dry sand in the shade because it doesn't have as much stress on it. So it's really an incredible plant, and it has those dense root systems. It's long lived, and it's pretty darn good looking.
I'm sorry,
So
which plant was that again?
that's the brown fox size Carex vulpinoidea, from the Latin vulpa for fox, vulpinoidea. And of course, if you want to create habitat, you need forbs because grasses and sedges are wind pollinated and they provide essentially no pollinator services. So if you want a high quality, and of course the seeds of the flowers are also used by a lot of different birds and other animals, especially smaller mammals.
One thing that I've noticed in after years of doing this is that when a basin is first shaped, the native infiltration rate may be pretty low because, even if you decompact it and so on, the soil has no structure. And so the inundation time that you mentioned might be a couple days if there's a little bit of dead storage in the basin. But once the plants get established and you go through some freeze thaw and so on, after a couple of years, it may be much improved. And I just wondered if you all had any thoughts about plant selection with that in mind, plants that could, maybe initially survive longer inundation, but then that decreases over time.
Well, I don't want to just talk all the time, but your tall prairie grasses they're incredible. And they'll put down roots 5, 6, 7 feet deep, depending on the soil type.
Mm-hmm.
And that's gonna open up that clay or that silty clay loam and gonna provide all those infiltration routes. And like I said, they'll grow super dry, they'll grow right up to the edge of a wetland, big blue stem and switchgrass, and to a lesser degree Indian grass.
And can they tolerate somewhat longer inundation, at least early in the cycle?
Yeah, if you read Curtis, Vegetation of Wisconsin, big blue stem is one of the dominants in wet prairies. And switchgrass, it's interesting, there's two races of switchgrass, at least. Okay, there's a hexaploid and an octaploid race of switchgrass, Panicum virgatum. And these have been documented since the 50s. And the octaploid, higher ploidy of 8 chromosomes versus the hexaploid of 6, the octaploid grows on sand dunes and sand barrens, and the hexaploid grows in swales, in wet swales. So here you have the same plant, same species, but they cannot interbreed because at apomixis, their alleles cannot blend because one has 6 and another has 8. So it's 3 and 3 and 4 and 4. So they can't interbreed, even though they're supposedly the same species. Anyway, point being is that switchgrass will grow basically right up to the edge of a wetland. It'll tolerate inundation for at least a week. Now, inundation also is a function of time of the year. In the winter, they can be inundated for a month and nothing because they're not growing. They don't need oxygen at the roots. But in July, you inundate them for a month. That's going to put them in a world of hurt because they need air to the roots. So timing of inundation is also a factor. But usually that's not a big deal in one of these basins. But those grasses are incredible, as is the fox sedge. And then you have certain species. We had a project on the west side of Madison where it was in 1993. We got 33 inches of rain in June and July at our nursery. That's off an entire year of rain in June and July of 1933. 1933. I remember 1993, and we had just planted with transplants a small detention basin in Madison, and the water was 7 feet deep for 2 months. And the species that survived was wild iris, Irish Shreve Ibergenica, or whatever they call it this week. Okay, and Carex lake sedge, not Carex lacarius. It was oh my gosh, really the big sedge that forms big mats, floats around in lakes, not lake sedge. Oh my God. Anyway, they were able to survive inundation, complete burial under the water for almost 2 months. I mean, 7 feet of water. It was a very deep depression. Oh, what the hell was that sedge? Anyway, I'll come up with it. So those are the exceptions. Everything else died. All these other wetland plants died. Okay, so that's the most extraordinary event I've ever seen. But you see, there are still plants that can tolerate these crazy fluctuations. So
Does anybody else have anything they'd like to contribute on that topic?
I think what we have been seeing, I'm sorry, what we've been seeing lately is dry falls and the need of watering transplants throughout the fall. Like last year, for example, where September and October were extremely dry, and all of our transplants needed a lot more management than we can usually plan for. That's my 2 cents.
But after that first season, they're usually self-sufficient.
Yes, usually they're self-sufficient, except for on a very dry spring, which, this spring is kind of shaping up like that. So I guess it's all TBD.
Anybody else?
Yeah, I think just reiterating on the seed mix, just having a good diversity of, 25, 30 species in that mix so that, as the soil does change, as the basin planting progresses and the inundation level quickens, as, the soil gets broken up by those early established plants, having those seeds in the seed bank, they will come up. We might not see them for 3 or 4 years until a burn comes through or something, but that seed is still there. It's still viable. So just having a good diverse seed mix, and yeah, maybe you're a little bit higher on some of those, early germinating species, so you get the cover, but as it progresses, and, we see this all the time in all of our natural areas that we're managing is, nothing is static, nothing stays the same. So having, diversity is going to be the key, is going to be the make it or break it. If you put a seed mix down that's got, big blue stem Indian grass and bergamot in it, like those are going to be the heavy hitters at the beginning, but as things change, they might start to fade out and other species will come in. And if you get disturbance in there from, maintenance, that's going to cause a plant community shift. And, as long as you got a good diverse seed mix in there, those plants will refill and reestablish.
All right. Well, how about the next slide, Neil?
And the species that survived that inundation was Chenoplectus americanus, formerly known as Scirpus americanus. So,
Okay.
so you know.
All right. Thank you.
Yeah, I want to make sure I get my numbers right. It wasn't a Carex at all. That's why I couldn't think of it. It was a Scirpus, now Chenoplectus. So E-match, E-control, region control strategies. You guys, I think this group has probably more experience than I do. We've had bad experience with core mats for seedings. This is different from transplants. This is for seedings. But you can see here, you got to have an erosion control mat or the game is over for sure. And you don't want too heavy a mat or else certain species can't emerge. And as I mentioned, Excelsior has worked well for us. You can also use jute matting, which doesn't have an inner core of straw or Excelsior, but it's pretty good if you don't have a high volume, high velocity situation. And then we use a nurse crop of oats at about 1 pound per 1,000 square feet, which is 43 pounds per acre, rounded up to 50 pounds per acre for rapid soil stabilization. That in coordination with the Elemus virginicus canadensis gives you really good cover the first year. And if you're doing a dormant seeding, you've got to have that in no later than mid-September because you got to have enough germination on that cover crop of oats, and you're going to triple the rate or quadruple the rate because this is a dormant seeding, and you want that oats to come up and really completely occupy that soil. You don't have to worry about it outcompeting the seedlings because they're not going to germinate till the next spring. But I think many people here probably have more experience with different things that they could outline and share.
Julia?
Yeah, on a lot of art projects, we're using a lot of the jute typically, but I've seen, now, I guess I'll just take this as an opportunity to kind of encourage either the Excelsior or the jute versus anything that's just avoid anything UV degradable in a lot of these situations. I've seen a lot of projects where those have been used and they don't as vegetation accumulates, they don't fully break down. And these basins do end up providing habitat, not just for pollinators, which we touched on quite a bit, but reptiles in particular, reptiles and amphibians will utilize these areas as habitat. And the e-matting measures that we have to take can interfere in both kind of a negligible way or a negative way. And so selecting for things like jute, or if you're using matting that, things that don't have the welded joints are safe for reptiles. Even considering the spacing or shape of the mesh can also be a good avoidance measure in terms of issues for reptiles. So something with more of an elongated rectangular mesh, it's easier for them to get out of and not cause harm to themselves. But that's just something on a wildlife note that I thought would be kind of important to bring up, because I have seen a lot of leftover EMAT when projects have selected to use the UV degradable, but the second that doesn't have access to UV, which will happen as vegetation accumulates, that can stay on site for years.
Just burn it.
I'm sorry, are you familiar with the DOT product acceptability list, Julia? Where they divided into different kinds of matting. One is called urban.
I'd have to look into that. I have to look.
Mat meets the criteria that you're talking about.
Good. Okay.
I'm really interested in other people's experiences with different types of mats and what they have found. Like as Julia said with the jute matting, did you have good erosion control with just the jute matting without any filler?
It was relatively small project site, so I mean, yeah, I haven't seen that on a large scale though, so I can't speak to that. But on some of the smaller scales that we've used it on, yes.
What I found is if you use a a nurse crop or a cover crop like oats, once that's up with the jute matting in that cover crop, within 3 to 4 weeks, you're in good shape. That's just my experience. So, but I don't know if you get a big giant event that causes really significant gullying or something. I didn't know if anybody had seen failure in those sorts of more extreme events.
Danielle and Raluca, did you have anything you wanted to add here?
We have only seen failure when the installation wasn't proper, but otherwise have also had really good success with jute and Excelsior.
We go to the next slide.
Yes, please.
Okay. So I changed this a little bit than the version I sent you all. I just changed this morning. So something I had forgotten to include. Oftentimes, in wetland situations, we can't use some of the more standard pre-emergent herbicides if we're using, again, this is for transplants now, not seeds. Oftentimes, the classic methodology for weed control in a perennial garden, which is similar to what we're doing here with transplants, is you put in the plants, you put down a pre-emergent herbicide, and then you put mulch around the plants. And that pretty much sets you up for the first year with very few weeds. Well, we have two issues, of course, in bioretention basins and other other water management situations, in that we may not be able to use certain herbicides because of the toxicity. And the mulch, as was pointed out earlier, washes away, accumulates, buries plants or seeds or whatever. But there are other alternatives, such as corn gluten, which is a non-chemical natural product that is good for usually, I think, 4 to 6 weeks for weed control. So you do have to reapply it. And you also have these new, like preen for vegetable gardens, these low toxicity pre-emergents that could be acceptable in a water in an aquatic ecosystem. And then if you're going to do the mulch thing, you could put down weed-free winter wheat straw or shredded hardwood mulch, but then you got to cover it with a biodegradable mesh, like just a mesh over it. No straw, no anything else. You just cover it so it holds it in place. And a classic methodology people use is you put down an EMAT, like your coconut that you mentioned, I believe, Raluca, and then you just cut a little hole in it and install your plants. And of course, if you're using this method, you always cut the holes in the same direction of the water flow. So they're parallel to the water flow rather than perpendicular, because if it's perpendicular, when the water comes, it'll just rip that mat up where you made that cut. So you always want your cut to be parallel to the water flow direction. And the smaller the plug, 50s and 72s, 32s, those are, I mean, people that put in quarts and gallons are just like, you got to be kidding me. It doesn't make no sense. It's expensive. You gain almost nothing. It costs you so much more. So if you use these smaller plugs, it's easier to install, less labor cost. You can put more plants in and you can put them closer together. That's the other thing. People put these big plants in, they can't get them closer together. With the small plugs, you can really cram them in there and try, hopefully, to reduce your weed density. Of course, you will get weeds germinating at the incisions in the emat, which will require regular weeding to keep them down. And I don't know, I'm sure many people have other strategies they've used that they'd like to share too.
Danielle?
Yeah, we don't do too much with erosion matting. Transplants, I mean, something you could do too is, in certain areas do bigger ones. Like if you have a subdivision where you have a couple basins or basins that are closer to residential properties or the entrance, like doing larger planting plugs, along those and putting those in. You can do the bigger ones in certain areas. And yeah, I agree. Doing the smaller plugs is it's way more economical. It's so much faster. If you got a drill and an auger, you can just, one person goes and the other people follow behind and get them planted. I mean, you can do with a crew of three, you can easily do a couple hundred of those in an hour. So it's a lot faster to do those small plugs, and they really do if weather cooperates with you and you get them in a good time, like they get established really quickly. Doing them in fall, if we don't have those dry falls like we did last year, but doing them in fall, you have really good success because they're already just initially they're they're cued to be going into dormancy and focusing on their root growth. So you may not see a lot visually from the top, but in the spring, they're going to be there and ready to go.
I had an audience question. Is anyone using soil stabilizing polymers under EMATs? Okay. Another question, and maybe this is addressed in a later slide. When is the best time to mow infiltration basins for maintenance? Spring,
We'll get to that.
late fall?
Yeah. We will definitely be getting to that. Yeah.
Okay.
And I have a question. Has anybody put in plants and then just put jute over it to hold things in place? It's something I have never done, but this is an interesting process we're going through here. Has anybody just put a jute matting over it to hold everything in place? It seems like it would work, but I've never done it. Nobody? Okay. Well, there's an experiment to try.
By the way,
So,
we've got time for one, maybe two more slides. So,
okay, here we have post-planting management proceedings, post-planting watering. I think that's it. Yep. Okay, so we're almost there.
good.
Okay. So post-planting management, we're at almost on time. So typically in the first year of a prairie or a wetland seeding, when weeds reach 1 foot, we cut back to 6 inches. You don't want to bring equipment in there and mess it up and rot it up, especially if it's damp. So string trimmers are best. Second year, biennial weeds can be a problem, like sweet clover, wild parsnip, burdock, etc. And all of these are determinate bloomers that can be stopped from seed formation by cutting them back to 12 inches just after they finish blooming. If you cut them before blooming or during blooming, they will rebloom. But if you cut them just after they finish blooming, they will not rebloom and the seeds will not have formed yet. And so you will stop that cycle of reseeding of the biennials. The only exception to this is Queen Anne's lace, Daucus carota, which is an indeterminate bloomer. You can cut that thing and cut that thing and cut that thing. It just reblooms. It'll rebloom from 3 inches tall. It's horrible. But that beautiful little Queen Anne's lace is the nemesis of the biennials. But all the other biennials that I deal with, including bull thistle and nodding thistle, all these biennials can be stopped in their tracks by stopping the process of seed formation by cutting them right after they finish blooming at 12 inches. And by the third year, if you can burn, assuming burning is an option, if you can burn in spring to remove old plant material to stimulate new growth, that's great. But Usually the soils can be too wet in spring, so you're almost required to do fall burning. If burning is not an option, you can mow everything to the ground, and that's gonna happen in the fall, because unless you can go in there by hand with a string trimmer in the spring. But if it's a large area and you have to use equipment, really the fall is the only time to go in because it's usually drier. Sure, people have other strategies they've used.
This is basically the playbook that we follow with getting a lot of our plantings established, and it's just really crucial, obviously, especially that first year establishment mowing. Just comment on Queen Anne's lace. I have seen it when we have units that we're able to get frequent fire in there. We've definitely noticed a decrease in the Queen Anne's lace density throughout planting. So as frustrating as it can be, if you can get frequent fire and there is a maintenance tool, it can really set that back. But fire is just, we prioritize that if we can. Obviously, you can mow it down, but unless you're kind of removing that thatch somehow, or that thatch is blown off in some way, shape, or form, thatch accumulation over repeated mowings, especially if it's poorly timed, can kind of smother your plantings too. So that's why it's kind of crucial to time it as you've laid out here on your slide, Neil, or prioritize once the planting is more mature to really focus on getting fire in there. Fire can do a lot for native vegetation, as a lot of us can sure speak to.
And also alternating fall fire and spring fire as often as possible. We've had great success. Fall fire on controlling Canada thistle, I can't speak highly of it. And even if we've been experimenting a little bit with growing season fire too. Sometimes even the good plants, the warm season grasses, are kind of taking over, and experimenting with growing season fire has really helped kind of redistribute the seed bank.
I agree. Have you ever used fire in mid-June against reed canary grass? That's an amazing, amazing thing. I didn't invent this. I read an article. Someone did this back in the 70s, I think. And I followed exactly what they said. And when reed canary grass is in full bloom around mid-June, if you have sufficient fuel accumulation from the last 3, 4, 5 years, you burn it in mid-June, and it just knocks that reed canary grass on its hind end, and the sedges and the native forbs recover. And you go back in there 2 months later in August, you're like, what happened? The reed canary grass is almost gone. And here you can see the sedges and Asclepias, incarnata, and verbena, and all this stuff coming up. Like, it's a miracle, because you're hitting the reed canary grass when it's most vulnerable at anthesis, full anthesis, when it's blooming and its roots reserves are at their lowest, or one of their lowest points, and it just knocks it right on its butt. It is the worst fire you will ever burn, unless you're burning poison ivy. If you've ever been in a poison ivy fire, then that's even worse. Yes. But the smoke is so thick and so acrid, and when you're laying down your backfire, your back line, it's brutal. You have to crawl, you have to lay down on the ground practically to get out of the smoke. But my God, the effect is incredible. And if you can't burn it in mid-June, or don't want to burn it in mid-June, you can go in, assuming it's dry enough, and you can mow it to the ground. It's not as good as burning, but it really, really does affect it. So it's amazing. It's absolutely amazing methodology.
Danielle, did you want to add anything? Go ahead, please.
Sorry, Leif, were you talking to Danielle?
Yeah, but
Okay.
if you have something to say, that's fine too.
I was just going to add that on the first year plantings, as we're talking about mowing, something that we kind of have to coach our staff through is with early seedings. Danielle had mentioned, you'll see sometimes a nice quick showing of rudbeckia, and you look like, I don't want to mow it. There's so much good already coming in, but along with that are a lot of these annual and biennial weeds that we're talking about. So those natives they'll come back, they'll return. It's still just really key to do the establishment mowings, even if you are seeing a good flush of some of these early establishing natives. Because don't be fooled, the problem plants are in there mixed in. So I just wanted to add that note.
Yeah, we do smaller scale stuff, so we like to do like string trimmers is our preferred method, and we just go around, and that way we can avoid, if we do see a good area that's establishing with a lot of native seedlings, we can avoid it and let it go to seed, because those are good seeds that we're adding more to the seed bank, and we can just go around and zip all the way to the ground, cut those biennials back. And yeah, if we hit some natives in mixed with them, not a big deal. It's better than using herbicide where you might be killing more seedlings than you can see. So it's just a nice, way to be a little bit more mindful and delicate in your mowing instead of taking a tractor in there. And like I said, especially if it's wet, you're going to do so much more damage by bringing in a tractor. And if people are moving these pieces of equipment, I wanted to mention this, from one project site to the next, clean your tires, clean your tracks, whatever you have, because if you're coming from a basin that's got a lot of teasel that you mowed over and you're bringing in soil to a new one that doesn't have teasel yet, guess what? Next year you're going to have teasel. This is something that's so frustrating to see these pieces of equipment moved from any kind of construction on the interstate, and you just see them covered in mud. And it's so heartbreaking because there's so many weed seeds that are probably being moved around, that we're just being negligent. And that's something that I think is written in some of the specs on construction, but people just blow it off because they're like, well, there's nothing there. We didn't see anything growing, and they're just lazy. So that little bit of work to clean off that any excess mud before you go to another project is going to be so beneficial.
Let's do the last slide really quick, and then we'll be at time.
Okay, so watering, should we or shouldn't we? Obviously, if you're putting transplants in the spring, like we talked about earlier, man, you want to have a watering system set up there, or some methodology of watering, because if you have a dry spring and you lose all those plants, oh boy, that's a big cost. And you may think you're out of the woods by July, but if you get a really dry stretch, you still want to be able to handle a drought situation with water. Once they're established after the first year, you're home free. And then, of course, if you're going to install transplants in September, and I would suggest that they be in no later than September 30th, so they have time to establish their root systems before the onset of cold weather. You obviously would want to water them in unless the soil is damp. I like to make sure they're watered in. And they shouldn't require any further watering that fall unless you have an extraordinary hot, dry stretch, but I've never seen a problem with that. The only problem is the next spring, although they are partly established, if it's dry in the spring, they're going to need water too under duress. So as far as seedings, a fall dormant seeding, they typically don't require watering the following spring, but we've seen dry springs where watering will make a huge difference even with fall dormant seedings because they're not getting rain, and there are certain species that have certain time windows of germination when the soil temperature is a certain temperature or day lengths or whatever. They only germinate at certain times, and if it's dry during that time, you will not get germination, and you'll miss a year, and those seeds may or may not overwinter another year to come up the second year. If not, you will lose that species from your planting. So watering is a really important insurance policy, especially if you have a dry spring or summer.
I've never watered any seeding, but I don't know if anybody else can speak to this. But if you water it too frequently, I've heard that can, inhibit the natives from germinating and growing well, and it will actually encourage a lot of the weed seeds to grow and germinate and fill in faster. So I've never done that, but on some talks that I've listened to, people talk like don't water. It's not turf grass. We're not planting grass seed that needs to be watered, every single day, for multiple hours. This is something that we just want to keep some of the soil moisture there so that they can germinate. I don't know if anybody else has any experience with watering. I've never watered seeds, so I can't say from experience if that's true or not, but it does make sense.
We have never watered seedings either. I do want to say that we have extended our planting season for the fall. Our cutoff date used to be October 15th, and the past few years we've been planting into November with really good success due to the very warm winters. If you're working with NVM, which we do work with also quite a bit, watering that is extremely crucial. Watering it daily, even more than you would water a lawn, I would say, for the first month or so.
I'm sorry, that was what you said with NDMs?
NVM, the native vegetative mats that
Oh, okay,
Julia
gotcha.
had mentioned earlier. We do work a lot with them. They're indeed extremely expensive, but if properly installed and maintained, just for the first couple of months before they establish, they're amazing. The seed diversity in them is excellent, and they establish so quickly. So it's pretty instant gratification with those.
I've seen, there's been quite a few springs in the last 10, 15 years where we had really dry stretches and watering made all the difference in the world for seedlings. And areas that, and you can see this when you have a sprinkler, an impact sprinkler that forms a circle. You can see the areas that might be missed on the edges, and the seedling density in those missed areas are significantly lower than the areas where they were watered. This is during extreme spring drought, and we're talking not daily, but more like weekly. But it makes a huge difference to maintain that soil moisture so the seeds can germinate. The other thing is, it's commonly not appreciated, is that people think, oh, well, we have to water sandy soils more than clay soils. And normally that is absolutely true because sandy soils drain so well. But what we learned in droughts of 88 and 2012 is that sandy soils actually are, although they're drier, the roots can penetrate down into the lower strata where there's moisture, whereas on a clay soil, that clay locks up, the roots cannot penetrate, and they die. So even though clay has a higher water holding capacity, the actual ability for the plant roots of seedlings to reach that water down below is cut off by the very nature of the very fine grains of the clay particles, which stops the root development into the lower substrata. So it's counterintuitive, but that's what happened. So you have to be really careful in a dry spring. You want to have water on there, but not, as you point out, not overwatering.
Well, we're at time or past time actually, so I'm going to thank you all for what was really like a master class in growing native plants. That was really wonderful. So thank you very much for participating. And as far as the workshop goes, we'll pick up again tomorrow morning at 8 o'clock. And like I said previously, once the workshop is done, we'll be sending out an evaluation form for people that want to get PDHs. So other than that, thanks again, and hopefully we'll see most of you tomorrow morning.
Thank you.
Thanks, Leif.